Good morning, everyone. My name is Allie Dunn, and I will be your host, moderator, and facilitator, at least for this first part of this Day 2 event. So welcome to the 28th Annual California Aquatic Bioassessment Workgroup meeting, or CABW, and the 9th Annual California Chapter of Society for Freshwater Science meeting. We've been doing this joint effort for the last almost 10 years with Angela and John and others at CalSFS. So just wanted to start by thanking them, and I'll be handing this off to Angela in just a few minutes to give her welcome from their end of things too. Okay, so before we really kind of dive into the event today, I wanted to take a few moments to kind of run through and acknowledge the land that the State Water Resources Control Board office is located on. We're here in Sacramento at the Cal EPA building. And this land was and still is a gathering place for many local tribes who've lived throughout the Central Valley and throughout the foothills for generations. And they were really the original stewards of this land. So just wanted to take a moment to acknowledge that. These people included the Nishinan, Maidu, Miwok people, and the Patwin-Wintun nations. And they've remained committed to the stewardship of this land over many centuries. And it's important for us to acknowledge that our organization sits on the tribal lands of Sacramento's indigenous people. We also recognize that we're here because of the sacrifices that we forced upon them. And in remembering these communities, we honor their legacy, their lives, and their descendants. So thank you. Okay, so as far as CABW, there's probably new people to this meeting. So I just briefly wanted to touch on who we are and what the purpose is. So generally, this has been going on for almost 30 years with kind of a three-pronged approach, all interrelated, which is to share current freshwater science research and management, to network and build partnerships, and to support science-based policy and natural resource management for the protection and restoration of California's freshwater aquatic ecosystems. So that second piece really of networking and building partnerships, that's a big component of CABW. Historically, we all get together, there's cold beverages that are had at the after hours, and that piece we're missing, right? Because it's all virtual this year as it was last year. And so, you know, I think we're all feeling that, and hopefully by next year we can get back to in-person kind of run a show. That said, we are completely virtual this year. So please be patient with us if we run into any technical issues, or if we run into any technical issues, and we will try and address those as quickly as we can. If you do run into any issues, you can contact the SWAMP email, and the email is there. If you want to jot that down really quickly, it's also in the slides, but it's swamp@waterboards.ca.gov. And again, just thank you all for your patience and working through us through these crazy, weird remote times. And like I said, hopefully next year we can all see each other again and not be computer screen faces. Just going to run through some housekeeping with the Zoom webinar protocols. So what's nice about the Zoom webinar is that it allows us to accommodate a larger audience. That said, we have disabled Zoom chat and the video and audio for attendees. However, there is a Q&A option. So we'll go through our talks later in the day or later this morning. And at the end of each talk, you can select that Q&A icon under your chat options. It's at the bottom of your screen in those controls. And there you can submit questions to us, and we have folks that will read those questions to the speakers. And again, any technical issues that come up, logistical issues, etc., please email swamp@waterboards.ca.gov. All right, so before I hand it off to Angela, I just wanted to kind of give a quick run through of what we have lined up for this first day of CABW. Angela will welcome from CalSFS, and we have our keynote speaker, Anacita Agustines with DWR here to kind of kick things off. And then we've got our first session, just a couple of speakers. We'll take a quick break, roll into our second session, take our break for lunch, and that also It's also the CalSFS business meeting, which Angela will talk to. And then we just have one last session of the CABW portion of the meeting in the afternoon. I'll kind of wrap things up from there, but then please remember we have a virtual poster session, which Angela, again, will talk about through CalSFS. And so Angela, I'm going to go ahead and turn it over to you, and happy to run through slides if that's easiest.
Yeah, that'd be great. Thank you. You can hear me okay?
Yep, loud and clear.
All right, so let's go to the next slide. Thank you. So my name is Angela Diploma Dow. I am the California Society for Freshwater Science Chapter President Chair. And on behalf of myself and our Treasurer, Secretary John Olson, thank you so much, Allie. Hi, John. There he is. Thanks. And we're so grateful again to be part of the CABW this year. This is a great partnership, and I hope it lasts for a long time. It's been great to be able to be part of this work group annual meeting for the last almost 10 years. Next year will be our 10th meeting, so I'm really excited. Hopefully we'll be in person so we can party. Okay, next slide. And then a big thank you again to the team, Ali, Shuka, and Anna at CABW for helping us put this together. And I do want to give a shout out to our CalSFS team, Christina Perisic and Ryan Peak for helping with the website. So we have a new website this year. We'll put the link in the chat for folks. And all the posters for the poster session later today are going to be posted there forever. We also have the posters from the last couple of meetings are up there as well. And a big shout out to our this year's 2021 CalSFS Fellows. This is our very first program of fellows. We have 5 fellows this year that got funding from the SFS, that's the Parent Society Long Range Planning Committee, to be fellows, and they've given back to CalSFS in great ways, and we're hoping to establish this long relationship with these fellows with the chapter as well as CABW. And also thanks to SFSS, our parent organization. And then all the students that submitted posters. We have 9 posters this year. It's great. And they'll be at the poster competition today at 2 p.m. And then tomorrow we have some tribal ecological knowledge panelists and a special session. And that'll be at 1 p.m. tomorrow. And thank you so much to all the panelists that are participating in that. I'm just so excited for that session and can't wait for tomorrow. Next slide, please, Allie. And so I thanked everybody, and we really just want to acknowledge the original freshwater scientists of California. And the First Nation inhabitants of the state, they lived, they worked with the land, with the water systems for thousands of years, without degrading systems, without allowing species to go extinct. And I really just want to, directly acknowledge them and thank them for leaving us these resources. And we really want to make sure that we're protecting and preserving them going into the future. You can click, Allie. I want to shout out to a system that I work in. So I work in Clear Lake. It's not to scale there, but I wanted to show you where it is in Pomo Land. Click, Allie. Thank you. And so Clear Lake is located in Lake County in Northern California. And we're just really appreciative for the original caretakers that are still there working the stewardship of the land and partnering with us and partnering in my work. And I'm just really thankful to be able to work in this wonderful, beautiful system. And so I acknowledge them and give thanks. And I've been doing some research, and one of the original names of Clear Lake, Hobbiton, which actually means big water or large water, which I think is a more apt name than Clear Lake. And if you're interested in about this system, we do have a special session panelist tomorrow. Sarah Ryan will be talking about the Thule boats of Clear Lake, and here's some photos there of Thule boats in the past and the present. I'm really excited for that session tomorrow at 2. And to the next slide, Allie. So let's just step back and talk about the purpose of the Society for Freshwater Science: to promote further understanding freshwater ecosystems and ecosystems at the interface between aquatic terrestrial habitats. And one of the goals of the Society for Freshwater Science is to foster the exchange of information among membership and other societies in the organization. And we believe this really aligns, working with CABW aligns with this message here to foster exchange of information. Next slide. So I just have 2 more slides. If you need to find out more information, we do have an annual newsletter, and we usually send them out about December, January, and we cover some things from this meeting, as well as highlight stuff that's been going on in our chapter with our students and some of our early careers and some of our researchers. We also have a social media. You can follow us on Twitter at CalSFS Social, and a really great shout out. Thanks to Christine for managing that Twitter throughout this meeting, as well as throughout the rest of the year. Next slide, please. And we do a brand new website, and we'll put that in the chat for everybody. And if you want to learn more about what we're doing and have any questions, you can attend the business meeting today at 11:45. We'll talk about our accomplishments and some other things that we have on the horizon for the next year. And then again, the posters will be today at 2 p.m. These are some great posters. We have some knockout students that put together some great research and management that's captured here in this poster session. And then tomorrow at 1, of course, our special session panel for our TEK. Thank you. Next slide. And this is all I have. So if you have any questions, you can email us at cal.chap.sfs@gmail.com. And if you want to support CalSFS and you are a member, or you just want to support us and future students, you can donate directly to us via Venmo, and that is the Venmo account right there, and that goes to our treasurer secretary. And again, thank you so much to Swamp and the Water Board for partnering with us, and we're really excited about today's meeting, and we hope everybody enjoys it. Thank you so much, Allie. Back to you.
Thanks, Angela. And yeah, the feeling is mutual. I think, as we move on year after year with CABW, it's awesome to have SFS involved with all the young freshwater scientists, and they're amazing. I mean, it's incredible the work that you all are doing. So thank you. Back to you.
Thank you so much.
Sure. All right. So to kind of kick things off today, we've invited and are honored to have Anacita Agustinas, the Tribal Policy Advisor with DWR, to provide our keynote speech. I'm going to go ahead and introduce Anacita, and then Anacita, I'll turn it over to you. And then following Anacita's talk, we'll have some time for questions and answers and some discussion. So kind of be thinking about that as Anacita is chatting with you today. So Anacita, like I mentioned, we are so honored to have you here. She is with the Department of Water Resources, so sister agency to the State Water Board. Anacita was appointed by the Department of Water Resources as their tribal policy advisor in August of 2013. She does a lot of amazing things. Her primary responsibilities are to provide policy support and recommendations regarding tribal issues to DWR's leadership. She's actively engaged with DWR's various divisions, assisting in tribal consultation and the development of DWR's tribal consultation policy. Before doing all of that, she served as the Native American Liaison and Manager of the Office of Legislative and External Affairs and the Office of Health Access at the Department of Healthcare Services. She previously was Assistant Director of the Office of Native American Affairs at the Department of Justice and the Office of Attorney General. And if you're not already impressed, her experience also includes developing and conducting training in the areas of tribal consultation, cultural competency, environmental justice, social justice issues, and legislative advocacy on behalf of California's tribal governments. So again, so honored to have you here today, Anacita. I think this is going to be awesome to try to connect those dots too to the session that we have tomorrow afternoon, and the talks that we'll have in between as well. So with that, I'm going to hand it over to you.
Thank you. Thank you, Allie. I appreciate that very much. So, Yate, on behalf of the Department of Water Resources, I wish to acknowledge the original inhabitants of the land where we work and reside. DWR's offices are located throughout the state of California, with our headquarters situated at the confluence of the Sacramento and the American rivers. This is the ancestral land of the Nishinan, Miwok, Maidu, and Patwin peoples, who have from time immemorial gathered on the east, the west, the north, and south of these important rivers and stewarded this land. Anacita Agustinas Ginishli, Twodichitni Nishli, Elakana Bashichin. As a Dene, I also wish to say thank you to the ancestral stewards of this land and for this opportunity to speak today. So I am the daughter of a Navajo mother who experienced and survived the boarding school system of the 1940s. And I'm also the daughter of a first generation Ilocano who immigrated to the Americas in the early 30s. And to you quick math thinkers, there was a 38-year difference between my parents, and a beautiful love story to be shared another time. When I was younger, I didn't realize it at the time. I thought I was just being an obedient niece. But during those early summers and winters of my childhood spent visiting my elders on the Navajo reservation, I didn't know it, but I was being taught by my family matriarchy the continuum and practice of traditional survival skills. One of my fondest memories is riding in the back of my uncle's pickup truck to the nearest trading post to fill up empty water tanks. Since then and to this date, there are very few community members with access to water, running water, and electricity. And at the trading post, we would park next to the water tank that serviced our community. And I felt that I graduated in stature when my cousins allowed me to suck on the hose to get the water flowing. This water was used for our crops and general daily use. I was being taught how to dry farm the cornfields and squash crop. So in the spring, we planted the corn and squash seeds, not in the custom straight rows I was familiar with, but the seeds were planted in pods to ensure their survival over the course of the hot, dry summers of the high desert. And these seedlings were dependent upon the monsoons and intermittent hand watering. The corn crop is one of the most important crops for the Navajo. It has ensured our resiliency and survival over many, many centuries. As Tribal Policy Advisor to the Department of Water Resources, I have the pleasure of working with California's tribal citizens and tribal governments from throughout the state concerning the many programs and projects that DWR is responsible for. We are responsible for maintaining the country's largest water infrastructure project and building the single tunnel conveyance project and the maintenance and operation of the various dams and hydro facilities along the state project delivery system. DWR administers several grant programs, and each of these grant programs and projects must consider the status of tribal governments as sovereign entities in our efforts to conduct proper community tribal engagement. So during the course of these next 2 days, you'll be hearing from your colleagues and statewide experts and tribal cultural keepers on various topics, recognizing the importance of incorporating tribal ecological knowledge into state policy as a sustainable practice. Tribal participation in your academic research and in development of program implementation is essential in working toward ensuring careful stewardship of our increasingly scarce ecological resources. There are many definitions, very different definitions of TEK. I'm not aware of any universal definition. In fact, there are various terms besides traditional ecological knowledge, such as indigenous knowledge and indigenous science, indigenous environmental knowledge, traditional science, and my personal preferences are tribal knowledge or tribal knowledge systems. Tribal ecological knowledge is a knowledge and practice that is handed down through generations. And it is a practice that develops a deep understanding of how to manage the resources within that landscape. My early example of corn planting on my reservation is a practice that continues to this day. And I'm proud that my 3 granddaughters recently shared that despite the extreme drought conditions in northern Arizona, their cornfield survived and they had a successful harvest. So my understanding of traditional ecological knowledge is knowledge that is passed down from one generation to the next. It is the way we interact with our land, the way we protect our natural environment to conduct ceremonies. It is our dependency on our natural environment. You cannot really separate the land from indigenous people. In fact, the way we describe ourselves through our names means the people of the land or the people of the water. TEK is collaborative. It's a collaboration through various spaces, such as traditional, cultural, and scientific space. In a traditional knowledge system, one will take into consideration community traditions, practices, and moral values, and combine that with the community's worldview in relationship to the land and environment. There is the reliance on generational knowledge as these rituals, practices, stories, and legends are passed down through cultural practitioners and wisdom keepers. To be a modern TEK practitioner, it means collaboration with our non-native allies. If you are a non-native ally, do not fall into the trap that works in one tribal space, thinking that what works in one tribal space will work in another. Knowledge is based upon the land and the space. It is through collaboration that you gain a better understanding of tribal land use and TEK. Keep in mind that there are over 200 California tribes encompassing many types of environments, that have practiced this generational knowledge since time immemorial. Tribal ecological knowledge is being recognized as a scientific practice, and traditional practitioner tribal ecological knowledge are also being recognized rightfully as cultural keepers and climate science and environmental science professionals. As we develop collaboration and partnerships, I urge you to recognize the environmental and ecological destruction through the policies and practice of California state government that displaced Native Americans. This displacement caused many tribes to be forcibly removed from their ancestral lands, yet despite this displacement, their knowledge has remained. Our current state policies are increasingly recognizing TEK as a cultural practice, and it is being incorporated into state policies. The challenge will be implementation, understanding, and incorporation to protect cultural, history, biodiversity, landscape, and traditional knowledge systems. It's important for non-Native allies and scientists to keep in mind that tribal knowledge can be co-opted by non-Indigenous researchers and their institutions. I believe tribal people feel this threat to their knowledge and information may be lost. Tribal sovereignty must be respected by recognizing the need for free, prior, and informed consent. Tribes should be involved from the beginning in order for consent to be discussed before tribal knowledge systems is accessed or information exchange. Please recognize that tribes have a right not to participate, which brings in dialogue concerning intellectual property and data collection. Few protections exist to protect this knowledge from the public domain and to ensure that tribal knowledge remains the right and property of the people. The risks are misuse and misappropriation that will impact cultural resources. Other risks are culturally inappropriate uses, the lack or loss of benefit sharing, such as what is the benefit to a tribe who chooses to share information? And finally, the avoidance of over-exploitation of scarce resources. So to grantors and institutions, your agencies need an ongoing relationship, training, directions, and guidance to ensure these protections. Discuss in advance what is confidential and how is that information to be protected. Recognize the role and value of different knowledge systems and incorporate into policies the policies of rights of nature and rights of rivers, plants, and other ecosystems. And consider what is the benefit to a tribe when data is collected during the grant process or through a state or federally funded project. What considerations are being made to presume ownership? Is the knowledge under the project, the institution, the individual researcher, or the author that is publishing that information? What is the benefit to the tribe or tribal practitioner for sharing this information? I would like to leave you with this final thought. Recognize the sovereign rights of Indigenous people to control access to and use of their traditional knowledge and their right to participate, give access or deny access based on their own tradition and processes, and consider how you implement the protections of this knowledge that is a gift from the Creator to Indigenous people. I wish you all an extremely productive 2-day sessions, and I wish you all the knowledge and wisdom through your partnerships and collaborations. And I've already seen that you have an impressive agenda to cover. Hefe, thank you for the honor to share these thoughts with you this morning.
Thank you so much, Anasita. I have a few questions that I was kind of thinking through as you spoke today, but I'd like to turn it over to our Q&A to see if folks, any of our participants had questions for Anasita at this time.
Yeah, but people are thinking, typing.
Okay. Yeah. So Anasita, being another agency person, I wonder, and maybe DWR has kind of gone this route, but how, we have our office that does a really great job at working with tribal liaisons in our Office of Public Participation. But is there a way to kind of create maybe a statewide, so like to truly integrate traditional ecological knowledge or indigenous knowledge for an agency to take that on and say, it's a priority for us, it's important, we're going to move forward with that? And how would you do that in a thoughtful way? Like you mentioned, there are over 200 tribes, so it's not just like an easy, we wrote it into a policy, therefore it's going to work and everyone's going to be on board. So what are some ways that from an agency perspective that you could kind of approach that, and does a formal integration into policy make sense?
Yeah, that's a really great thought in terms of what we need to do as agency. I definitely think that formal integration into policies is most important. We have executive orders that exist, but unless those are codified via statute or other types of mandatory language, it could get lost. And there could be administrative shifts. And we've seen that, in the 60s, 70s, 80s, 90s, extreme shifts based on just federal mandates or state mandates. Governor Newsom in 2019 set forth an ancestral lands policy. And I believe that actually that was 2020. And his statement on ancestral lands, which states that state agencies need to incorporate traditional ecological knowledge into state policy and planning in working with tribal governments. That's a start, but that's an administrative policy right now. And if legislation can pick up upon that kind of knowledge sharing and have that part of it, and what I mentioned earlier about the grant process, as we develop grants, and I know State Water Resources Control Board is a great partner in developing lots of grants, even with DWR on habitat restoration, utilizing TEK knowledge. If we can, step back and make sure through our guidelines and regulations, not only are tribes should be direct recipients and make the hurdles easier for tribes to receive the funding to do their own research, but also the protections I mentioned that fall under data collection and intellectual property. I think that's another strong area that's going to be an opportunity for tribes to really help develop some guidelines. But I think that would be a fantastic start.
Awesome, thank you for that. And then just kind of thinking of, we've got agency people on the call or on the Zoom webinar, but there's also a lot of new scientists or, scientists in school and going through that whole process through universities, et cetera. And I know for me personally, I went to CSU Sacramento here locally and went through their habitat conservation program. And at the time they didn't have really they didn't touch on indigenous knowledge at all, really. And I wonder if you have any experience with that, if there are maybe ways to get young scientists more connected with the land through universities and through kind of our academic institutions, and what your thoughts are there on that.
I'm seeing more and more, especially, Sacramento State, UC Davis, and some of the other Cal State systems. The universities are being a little bit more proactive through their Native American Studies program, and not having that be siloed as a liberal arts area, but also utilizing that as foundational for some of the science-based programs. I think that's something there that needs to be coordinated statewide through that. I mean, we're seeing, and today, yesterday and today it's being Indigenous Peoples Day. We're seeing, lots of legislation dealing with curriculum, mainly starting, with the K through 12 curriculum. But I think that curriculum starting there will obviously translate up, to post 12 into undergrad and graduate programs. And I think there's going to be some good collaboration there within that academic research. I think understanding, California's history, as scientists, mainly probably going into a scientific path, some may not have the liberal arts studies opportunities, but you cannot take a look at any kind of environmental landscape view without understanding what I mentioned earlier about ecological destruction, environmental destruction, and its impact on Native American people, and that's state policies. And so they have to go hand in hand if you're doing anything along land and water in California regarding what those policies have done to Native American tribes.
Yeah, well, and I'm happy to hear that CSUs and universities are starting to kind of cross over a little bit more and integrate some of that into the scientific programs. Because I mean, I'm kind of feeling that, especially lately, that there is somewhat of a disconnect sometimes between the people and the land, right? And just learning more from those that have lived by the land for centuries. I think that's one way to really raise up next generations of true stewards of our land and water resources. And what better way than through not just colleges, but like you said, get them while they're young, K through 12, and well, 12's, you're getting kind of old there, but you go, for the younger folks to really get them excited about the land and understanding it. And I'm just going to check over. Do we have any other questions, or I'm happy to keep asking because I've got lots to chat with Anasita about.
Yeah, go for it.
Okay. And so we kind of talked a little bit about the, young scientists and academia world. Going back to an agency perspective, I mean, I'm familiar with our work through our monitoring programs, how to connect with our Office of Public Participation and Tribal Affairs there. Is that something similar with DWR, where if you're new to agency and you're starting on a grant project and want to be working with a local tribe or what have you, how do you go about that is it just an email, or what are some of the resources, I guess, if I put it another way, for agency folks to work with tribes?
Well, I like to start at, if it's a funding project or program, number one is, where's the money coming from? Obviously, through a state agency, this is coming from legislation mandated through our agencies. So we have to create guidelines and regulations for that. And I really would like to see guidelines really set forth, tribes in specifics versus what we see now is tribes being on the same sentence as underrepresented communities and tribal governments versus, and then the term itself of the word stakeholders. We're stepping away from the term stakeholders in our department, also as being kind of it is a racist term, and it's a colonized term that when you're talking about engaging the public, utilizing the term stakeholder, that comes from the doctrine of discovery, planting a flag, creating boundaries on land that already belonged to people, and even in the gold rush experience of what was done to the colonization process in California. And so we're trying to use language like communities of interest, partnerships, communities, because what does stakeholders even mean? And it's agencies have utilized, we're going to reach out to stakeholders, and it becomes kind of like, the equivalent of the Wall Street blue ribbon panel. It's the same kind of big eaters, we call them, that come to the table versus, and it's an easy way to say, we're going to reach out to our typical usual suspects. And already that's a narrow viewpoint. And so we take away just how we look at stakeholders in general, even the terminology, and talk about communities. And then we develop who is the communities that we need to engage with. And we take out language that have not been inclusive in terms of how we reach out to underrepresented and underserved communities that have not traditionally been a part of that process or part of that outreach. And then I think that obviously guidelines of how then do you interact with these communities, and make sure, because when it comes to stakeholders, it never recognizes that tribes are not a stakeholder, they're tribal sovereigns, and that they should be treated separately even amongst the communities and other partnerships on that government to government basis. And I think that we're just starting to understand that through our literature, the websites we have on agencies pages. We always try to make sure that we have a tribal tab that shows our government to government relationship building process, that there's information there specific to tribal governments on any of the programs that we do. So those are just some general first steps in as you create these partnerships. But I think that really starting from language is super important. And that's something that we're trying to do at our department.
Yeah, thank you for that. Yeah, I mean, there's a lot of work I think that we still have left to do. And, you know, within the water boards, there's a similar movement too, and a lot of training that's happening, which I've been at the water boards for about 10 years too, and just seeing more and more of that, and kind of changing our terminology too, I think is critical to that. So thank you, Anacita. It's we're about at our time, but I want to thank you again for your time. This was an excellent discussion with you, and hopefully we can, I have more I want to talk to you about, so I'll be following up just to talk a little bit more about some of these biological monitoring programs and how we can do better within SWAMP to work with and support the tribes throughout the state. So thank you so much. And if folks have questions for you, I think they may be emailing you, so be aware of that.
Not a problem. Thanks, everyone.
All right.
Bye.
Bye. Thank you. All right. So, and folks, if you do, you know, you're drinking your coffee, still getting caffeinated maybe, but if you do have questions that you think of and that you want to run by Anacita or discuss with her more, you can reach out to myself or Shuka, and we can connect you with her. I think her contact information may be available as well. But if you can't find that, please feel free to reach out to us. And if you want to carry on that discussion, I think she'd be happy to do that. Okay, so like I mentioned, I am your moderator again for this next session. Throughout the next couple of days, we will be handing off, it won't be me all the time, so you're lucky. You won't have to hear my voice for 2 days straight. However, we do have this first session, which I'll be moderating. There's a couple of really great talks. There's some nexus here. We're kind of, if we were to group this, there's a lot of really great watershed monitoring that's happening in a local watershed here, local as in the Bear River watershed. And then we're going to move over to the Central Coast for the second talk and hear a little bit about work that's being done there with monitoring and some new monitoring tools. So with that, I'm going to go ahead and introduce our first speaker and just make sure, Alexandra, are you on and able to talk? And
yep, I'm on.
Okay, awesome. Hi. So Alexandra Cisneros Carey is with the Sierra Streams Institute, and Alex graduated from UC Berkeley with a degree in environmental sciences and forestry in 2020. She focused on California plant and vertebrate ecology and natural history, and as an undergrad, developed a passion for research and experimental design while working for freshwater ecology and plant physiology labs. She served as Sierra Stream Institute's AmeriCorps River Scientist in 2020 through 2021, and currently runs the Water Quality Lab and Volunteer Monitoring Program. Alex is interested in data-driven conservation research and the impact of climate change on California's plant communities. And she is applying to graduate school for ecosystem ecology. And with that, Alex, I will turn it over to you.
Hello, everyone. Thanks for the introduction, Ali. I'm Alex Carey, and like she said, I'm the Water Quality Lab Manager for Sierra Streams Institute, And today I'm presenting on Community Science Resilience, a 20-year review of watershed monitoring with Sierra Streams Institute. So first I'm going to give a bit of background about the organization, and then we're going to get into the data and the trends we're seeing. Okay, so Sierra Streams Institute is a community science watershed research nonprofit. We're located in Nevada City, California, which is and in Nevada County, which is the red county outlined in the California in the top right. And we started in 1995 when a group of community members wanted to know how a bridge being built over Deer Creek, which runs through town, would affect water quality. So they organized themselves to start monitoring water for the city. And that grew into Sierra Streams Institute today, where we go out every single month and we train citizen scientists to collect water quality parameters and in the field, and then bring back samples to test them for E. coli and nutrients in our laboratory. And besides monthly water quality monitoring, we also do swamp bioassessments in June and October. And we're actually in the middle of one of those assessments right now, where teams will walk up the creeks and collect algae and benthic macroinvertebrates, which are those two photos below. So these are some images of the watersheds we monitor. Deer Creek is in the top left, and that's our home base watershed. We've been collecting here for not like 20 years now. And then Bear River watershed, we only recently started collecting from in 2016. And they kind of fit together like puzzle pieces. You can see a bright green watershed in the Nevada County in the top left. And right underneath it, like it, not quite perfectly, but the Bear River will start, and both of the headwaters of the watersheds are up along Highway 20 on the way to Tahoe. So the water quality parameters we test for are air temperature, water temperature, dissolved oxygen, conductivity, pH, turbidity, and then in the lab we test for nitrate and phosphate, as well as E. coli. And long-term data sets like these are super valuable for understanding the impacts of climate change on watersheds in the Sierra. Sometimes the impacts of climate change are really subtle and will be a slow buildup. So it's important to have like a long-term data set to compare things to. But sometimes in California, there are more intense problems, like, or more, the impacts are more intense and sudden, like wildfires or droughts. And in our local community, wildfires become more of a problem since we're in the Sierra Nevada foothill. And this hit very close to home in August 2020, which is the slide, it says 2021, but it was in August 2020. We lost our office to the Jones fire. I don't know if people remember, but back in that summer during August, 6,000 lightning strikes hit the ground in California and caused a lot of wildfires all over the state, including the Jones fire. And you can see the burn scar of the fire on the left of the screen. And somewhere in the middle of that is the Sierra Streams office. So we lost our building and our instruments, as well as all of our lab equipment, but no one was injured because the pandemic had already started. So everyone was working from home. So it was a hidden blessing. And we also still had our 20-year data set saved up. So this is a reminder to save your work on the cloud, because your office could burn down and your desktop will be lost. But because we still had our data set, we could rebuild our monitoring our program as soon as we got the equipment again, and as soon as we had a space to store and start running our lab analysis. So before we restarted the program and brought back our volunteers, we had a good opportunity to reprioritize and look at what was working with the monitoring program and what we could be changing and what we would want our program to focus on for the next 20 years. So one of the first things we did was look through the data set and try to find what sites were serving as indicators for other parts of the watershed. So maybe one site was really tracking the same trends as another site, so much so that we could just use that latter site to know what was happening in that part of the watershed instead of going out to both sites, which would save time and resources and allow us to focus on parts of the watershed that maybe were more understudied or maybe had more vulnerabilities. We also wanted to know where in the watershed the impacts of climate change were already being seen. So we found which sites were potentially most vulnerable, which sites were being changed the most in terms of our trends, like maybe they were having the higher rates of nutrients or higher water temperature trends than other sites, and which sites then could be more resilient to climate change, potentially as climate refugia. For example, in the top part of the watershed, the first green dot is site 1, which is the headwaters. And while most of the watershed is increasing in water temperature, that site is staying pretty level because of it's a pretty non-impacted area. So potentially that could be protected as fish habitat or climate refugia for things that can't really handle the changing water temperature trends. And we also wanted to know what places we could monitor to understand the impacts of wildfire in our area. For example, we recently started monitoring more sites on the Bear River. We're working with Placer and Nevada County to track the impact of another different recent fire that started this past August called the River Fire, which actually started right next to the Bear River. So we're going to start tracking to see how the burn scar will move into the river and how it will impact water quality as the first winter storms start coming in. So here's a graphic of some of the predicted trends under climate change. The left side of the graphics relevant to California. So California is going to experience hotter and drier conditions in the coming years. And those hotter, drier conditions will cause the water temperature to increase in our streams, as well as to have like lower water levels in general. And when the streams are getting warmer, that means that dissolved oxygen levels are decreasing because the solubility of oxygen decreases as temperature increases. And we're also going to see more severe droughts, and having less water in the streams means that there'll be higher levels of conductivity because there'll be higher concentrations of minerals or nutrients floating in the water, which in conductivity is another thing we test for. But climate change isn't all just linear lines. Sometimes it also just means more dramatic seasonal variation. So we're going to see a lot more flashiness or crazy variability in our graphs due to climate change. So let's see. These are just a few of the parameters that we test for: air temperature, water temperature, dissolved oxygen, and conductivity, all for Deer Creek from 2001 to 2020. And you can see from the slight uptick, air temperature is slowly increasing in Deer Creek since 2001. And you can see this seasonal variation between winter and summer. And rather than everything just getting warmer, it's more looking like that the winter lows are getting warmer than they used to be, so they're not as cold. Whereas the highs in the summer, while they're not steadily jumping up and like jumping forward, they're staying about the same and having less variability. And that is mimicked in the water temperature graph, where the winter lows are getting warmer and the summer highs are staying about the same. And in a different watershed, we might see a higher warming trend for water temperature, but Deer Creek is broken up by several reservoirs and dams that do bottom releases of cold water. So while the whole watershed is slightly increasing in temperature, there are some sites that aren't experiencing that warming trend, or even experiencing a slight cooling trend, just because it's not like a natural flow of water. It's still controlled by the irrigation district. And then if you go to the bottom right, dissolved oxygen, it's slightly decreasing over time, which falls in line with our predicted trends from the previous graphic. And the data points are also getting more condensed, which suggests that maybe we're getting better at collecting dissolved oxygen and training our volunteers and citizen scientists to know what is a normal reading and know what is standing out maybe is an instrument error. And connectivity, the red line is actually slightly decreasing over time, which is not what we predicted. Connectivity under a drought, we would think would be increasing over time because there's less water. But again, this might be because the Deer Creek watershed is not a natural system. It has a lot of water input from the city and from the irrigation district. So maybe they're keeping it high enough that it's not lowering to increase connectivity. And these graphs are for the Bear River, the same parameters: air temperature, water temperature, dissolved oxygen, connectivity. And you can see the air temperature and water temperature and dissolved oxygen, well, air temperature and water temperature are increasing over time, and dissolved oxygen is decreasing, which falls in line with our predictions under climate change. But unlike in the Deer Creek system, Bear River connectivity is increasing over time. And that could be because the Bear River is a really impacted river with not much protection. It can be kept at very low levels because it feeds into the Yuba and feeds into other irrigation districts and isn't kept at as high a water level as Deer Creek, as they like to keep Deer Creek. And it also goes through more degraded sites like quarries, which could have higher runoff that would increase the ions in the water and increase the connectivity. So the fact that it's increasing so steadily maybe is a sign that we need to do more regulations and more monitoring of the Bear River system, since it's a really huge watershed that starts again up towards Tahoe and goes all the way towards Yuba City. And here is a graph of water temperature and dissolved oxygen as a linear regression. So this is for just the Deer Creek system. And we can see the relationship really clearly where water temperature is increasing and dissolved oxygen is decreasing. But then if you break it up by time of year, so the dry season and the rainy season, you can see that it isn't quite as, like it does matter what time of year it is and the water levels. So the dry season, it's a tighter fit, so which makes sense because when it's summer, the air temperature is a bigger input on the water temperature. So dissolved oxygen is probably more highly following water temperature. But when you look at the rainy season, while there's more variability, there's actually a steeper relationship. And that might be because in the cold season, despite there being a lot of variability, the water temperature, the shifts in water temperature more intensely trigger the shifts in dissolved oxygen. And that might have to do with the fact that, the winter is winter here at least has a really broad range in temperature. So it is a greater shift that could be occurring. But the variability could be from the fact that not every rainy season is very wet and there's a lot of dry. There's often a lot, like due to the drought, there's several months that usually were raining but are now pretty dry. And that could explain why it's less of a tight fit relationship. But these are just two of the related trends from what we've gathered, and there's a lot more to explore in both the Deer Creek and Bear River watershed. So if you have any questions, you can email me at alex@sierrastreamsinstitute.org, or you can ask them in the chat. But thank you for listening.
Awesome. Thank you, Alex. Right, video. All right, there we go. I'm doing great over here. No technical issues. So we do have some time for questions if there are questions, and just a reminder, I'm going to go to this next slide. If you go to your Zoom webinar, there's a Q&A button. Click on it and you can ask away if you have questions for Alex. And it looks like we may have a couple.
Yeah.
So Alex, we've got a question for you. What kind of trends are you seeing with benthic macroinvertebrates?
Right. So depending on the site, there are different trends. We are seeing in the Bear River that the benthic macroinvertebrates are, it's a smaller community that we're gathering, and usually BMI can indicate water quality health. So depending on the health of the water, we're seeing more diverse communities in the more protected and cleaner parts of the Deer Creek compared to the more degraded Bear River sections.
Awesome, thank you. And we've got another question for you. Which sites had the highest water temperatures, and why do you think that they did?
The highest water temperatures occur in the lower parts of both watersheds because they're lower elevation, and also they're a lot more open. We go from mixed conifer forest in the upper watersheds of both Bear River and Deer Creek to open oak woodland. So there's a lot more sun hitting the water, which is increasing the water temperature in general. But that's also complicated because again, there are several dams for Deer Creek. So right underneath the dam, the water temperature tends to be a lot colder than the surrounding areas.
All right, and we've got a few more questions rolling in. Do you store the macroinvertebrate data, or have you developed an index of biological integrity at all?
We do store the BMIs. We store them in ethanol, and we actually have a pretty long-standing volunteer program where volunteers will come in and sort and ID the insects. And I think we do have an index of biological integrity. I think a previous AmeriCorps developed it. I haven't seen it, but if you email me, I can send it to you.
All right, awesome, Alex. There's more questions, and I think we've got 3 minutes, so we'll work through what we can. Are there stream restoration projects in your monitoring area? And if so, have you seen any changes in water quality?
Yeah, we have 3 of our sites are on a property that we have access to. We call it Deer Creek Ranch, and we have a long-standing restoration project there where we're planting willows and other shady trees by the water to increase or to decrease water temperature through shade. And also we also plant like nitrate fixing plants, so to prevent like runoff from going into the water as much. But we're looking for more projects too.
All right, and how about your community volunteers? Do you find that you have a pretty consistent and good turnout with those guys?
We have, we're really lucky to have a lot of volunteers who have been with us for the entire 20 years of Sierra Streams. There was a bit of a lag after COVID as people were like hesitant to leave their homes and come out and help. But it's a really great community up here of volunteers who love Deer Creek and love getting out and trying to understand what's happening, like how climate change is impacting their surrounding area for themselves. So we have it's a pretty consistent community.
All right, and another question, how about the trends in percent concentrations of O2 and specific conductance at 25 degrees Celsius?
Yeah, our dissolved oxygen concentrations are decreasing for both watersheds, but I haven't looked at it based on at just 25 degrees. So maybe I'll add that to my list of data questions.
Awesome. All right, a few more, Alex. You got a lot of interest here. So how do you analyze the nutrients, and are your data available in CDN?
So we use a Hawk calorimeter in the lab, and they send us test tubes for phosphate and nitrate. So we just add the samples with pipettes and put them in the calorimeter, and that's how we estimate it. And we do enter our data into CDN. I don't know if we've entered it recently due to the fire, but we're going to get that rolling again soon.
All right. Awesome. I know it's time consuming.
Yeah.
to get it in. And then a couple more questions here. I don't know if we'll get to both of them. As far as the bioassessment monitoring, are you following swamp protocols? And
Yep.
is that, you kind of address this if it goes into seed-in, which it does as time allows.
Yeah, we're not doing the physical habitat surveys this year. We're just doing algae and benthic macroinvertebrates, but yeah, we're following the protocols.
All right, awesome. And there's one more question, but in the interest of time, I think we'll copy that question over to you in the chat so you can address it separately. But again, thank you so much, Alex, for this excellent talk, and hopefully we'll be working with you soon.
Thank you so much.
All right, bye. Okay, so our next speaker then in this session is Sarah Stinson. And Sarah, you should have control. Looks like you do. Sarah, let's see here. That's your abstract. Sarah is a PhD candidate in ecology at UC Davis in the Conan and Lawler labs. Her current research focuses on effects of pesticides of emerging concern on aquatic invertebrates and fish. Research focuses using molecular techniques and behavioral assays. Her professional interests include aquatic ecotoxicology, molecular ecology, and environmental justice. And in addition to her scientific pursuits, she was a professional dancer for 15 years and teaches dance classes in Sacramento. When not pipetting small volumes of clear liquids into other liquids, she's usually camping, coding, or crafting. Nice to have you, Sarah, and I'm going to turn it over to you for your talk.
Thank you, Allie. Can everybody see me and hear me?
Yep.
Great. I'd like to thank the organizers for having me. It's a real honor to be here, and I'm excited to talk to you about this project, which will be the basis for one of my PhD chapters. And today I'll be talking to you about macroinvertebrate distribution across an impacted watershed in the California Central Coast, and some of the implications that this project may have for future monitoring efforts. Oops. And it's not letting me forward my slides. Oh, there we go. Maybe there was just a little bit of a delay. Here we go. I'd like to acknowledge, first of all, the various individuals and organizations who have helped make this project possible, including my academic advisors, as well as the Department of Pesticide Regulations who funded the study. Special thanks to Xin Dang and his team for all of their support. And also some of the people who have provided both library preparation assistance with my sequencing samples and also analysis assistance with the bioinformatics. And lastly, I would like to acknowledge that these samples were collected on lands that were traditionally held by several indigenous tribes of California. So some of you may already be very familiar with this study system, but I'll go ahead and give you the overview in case you aren't. The Salinas River watershed is located on the central coast of California. It's an important riparian corridor for many species of concern, some of which I've pictured below, who either use the river itself for habitat or the surrounding riparian land. Unfortunately, this area is also heavily impacted because of urban and agricultural land use. So swamp and other state agencies do monitoring here, both looking at water chemistry and biological integrity at several sites through this area. So some of the bioassessment methods that have been used previously by SWAMP and others are looking at macroinvertebrate benthic communities, as you heard from Alex's talk previously. And the map on the left shows both Monterey County and San Luis Obispo County outlined in purple. And here are the previous California Stream Condition Index scores that have been attained from previous swamp monitoring efforts in this area. And as you can see, there's a very wide range of CSCI values that have been obtained throughout the watershed. And the downstream site of the Salinas River, which is at the top left of the map here, has consistently yielded very low water quality, and in other studies we see frequent detections of many chemicals of concern, usually agricultural pesticides and others. So this is an interesting study area because it incorporates a wide range of habitat quality. And these assessments are, as many of you know, are difficult and time consuming and often require taxonomic expertise, which is limited. And having done some of this traditional bioassessment myself, I can testify to the fact that it is very difficult and time consuming. It's a difficult process. So in this study, I set out to answer a few different questions. The first, more basic question is, can we even detect these sensitive species using eDNA, environmental DNA metabarcoding in this watershed? And not just the sensitive organisms, but can we also detect maybe key invasives or specific threatened or endangered taxa using this method? And then also I was curious to know how our previously assessed CSCI scores aligned with these detections in the metabarcoding data, and comparing most versus least impacted sites and how their taxonomic distribution varied with this method. So I'll go into that now. Briefly, we collected samples from sites, 23 sites throughout the watershed. This included both the main Salinas River, but also its major tributaries as well. And for these sites, I picked 3 transects, which were downstream from riffle habitats, and collected 50 milliliters of sediment across 10 subsamples, which we determined from previous pilot data that this would be sufficient to find rare taxa. And we also went ahead and collected some additional samples from the highest quality sites. So we added water filtrate to our sampling for those sites, as well as traditional kick netting, which I used 3 kicks across each transect for the 3 transects. Additionally, we also measured water quality parameters, dissolved oxygen temperature, conductivity, pH, etc. And for all of the molecular samples, they were put on dry ice immediately in the field and then stored at -80 to avoid any degradation of our samples. And the methods, I could spend a long time talking about them, but I'll keep it brief since I think the results are more interesting to discuss. But if you're curious to know more about any of the steps that I took in the methods, I followed the Cal eDNA projects protocols, which are available online in great detail. So you can go on and download in-depth protocols for each of the steps. And as part of this study, I looked at several different primer pairs, different markers to target different taxonomic groups. And for this talk, I'm only going to be talking about one of the CO1 markers, which is very good at finding invertebrate taxa, but some additional analyses is currently underway for these other markers as well. And the sequencing was performed at the Genome Center at UC Davis. This slide has a lot of information on it. I think it's important to communicate what steps are performed in any sequencing study once you've reached the bioinformatics stage. So on the left, you'll see I followed the Crux and Anacapa pipelines, and those are basically a way to generate custom reference sequence databases to assign taxonomy to the DNA sequences that I obtained from my samples. And then Anacapa sorts those by sample and by marker, matches them to their taxonomy, and performs quality control and filtration. We also performed several quality assurance and quality control steps throughout this process to ensure that the taxons that we were seeing were actually representative of our sites and not some result of cross-contamination or laboratory contamination. So just an overview of what we found from this particular marker. In our sediment samples, we detected common families in our sequence data, including chironomids, simulids, so all taxa that we may expect to find in a benthic sample. So that was consistent with our sample type and with these locations. We were able to identify more fish species from our water filtrates, which is perhaps unsurprising because we have perhaps a better representation of fish in the water column versus in the sediment, unless you had some tissue samples being deposited into the sediment. Interesting though, we were unable to match 35% of the sequences obtained with taxonomy in the reference database. This could be a function of the fact that taxonomic sequence databases are still being developed, and some taxonomic groups are not well represented in those databases yet. So this is perhaps something that could be reanalyzed at a later date, and we could obtain additional taxa as those databases become improve on their coverage. So we, on the left-hand side, on the top graph here, this is showing the total number of sequence reads obtained from each of our samples. And I included that to show that we didn't have any outliers as far as being unable to obtain sequence reads from a sediment sample. Sediment is a difficult sample type because you can have microbial action or other PCR inhibitors that might prevent you from being able to amplify and identify your sequences. So we did obtain a good number of reads from all samples, and those reads were assigned to what is referred to as amplicon sequence variants. This is similar to OTUs if you've seen other metabarcoding studies, but basically it is a way to cluster sequences into related groups without assigning taxonomy. So these are closely related sequences, but not assigned to taxonomy. But then on the right, we show that they were assigned to over 1,600 species and across 29 phyla. So this marker is designed to capture a broad range of taxa, and we were able to do that. Oh, okay. I do not see my Venn diagram showing up in this slide. I'm not sure why, but I think there's sufficient information here that I can describe it briefly. So we wanted to compare what sorts of taxonomy we were obtaining from our water filtrate versus sediment. And the number on the left, the 86, is the total number of family level taxa that were obtained from a water filtrate for one of our sites, one of the more in theory, biodiverse sites. And on the right, we obtained 34 sediment specific family, and 42 is the number that was overlap. So between these two sample types, we saw some overlap in the family level taxonomy that we discovered, but significant differences as well. So apologies that this Venn diagram doesn't seem to be showing up, but I'm happy to send you the slides if anyone is interested to see them. Moving on to some of our sensitive macroinvertebrate species, I was curious to see what detections we were obtaining for these groups specifically across our sites, and I organized this by CSCI score. So at the top left, you'll see the lowest score, followed by the sites that had no previous score, and then moving up in habitat quality index. So in summary, we detected these sensitive macroinvertebrates only in sites that had a previously determined CSCI score above about 0.7, which is in that 0.6 to 0.8 category. And increasingly as CSCI score increased, which is consistent with what we expected to find, which is that sensitive macroinvertebrates do not do well in sites with poor water quality or poor habitat quality. There we go. Next, we were interested to look at the amplicon sequence variance detections per CSCI score for our sites. And again, this is indicative that we are detecting sequences and from even low quality sites. So we're not seeing any PCR inhibition that would swamp out our ability to detect sequence reads in general, and that we do see a slight increase in these numbers at higher CSCI values, but it's not a consistent increase across CSCI increased values. Looking at family level taxa per CSCI score, we do see that in our highest quality sites, we do see a slight increase, but again, it's not necessarily a linear increase from lowest to highest. So we are seeing different biodiversity representative in the lower quality sites, not just a lower number of family level taxa at these sites. So then I was curious to look at the dissimilarity between the sites based solely on their CSCI value. So this is a non-metric multidimensional scaling plot. It's set on 3 axes, which I've rotated a little bit so that you can see the clusters more clearly. But basically, groups that cluster further apart from other groups are more dissimilar. So if they're close together, they're more similar. If they're further apart, they are less similar. And you can see that our lowest quality sites definitely differentiate, and they are much more dissimilar than the higher quality sites in general. Although there is some differentiation of the most high quality sites, this does overlap slightly with the 0.8 to 1.0 level. And then kind of reaching the end here, I've just got 1 or 2 more slides. Next, I wanted to look at how is dissimilarity represented across both the water quality and the water body that these sites were collected in? Because in theory, if you have higher hydrologic connectivity, you may have a better chance of dispersal for a lot of these groups. Different groups have different dispersal methods and distances, of course. But this was just to look at water body in general. So Tembladero Slough, which is TEM, and Sal DPR, which are the most highly impacted sites from the study, are clearly much different in their sequence data than other sites. Salinas River is also separating out from many of the main tributaries, which is interesting. So this was a preliminary foray into my metabarcoding data set. There's a lot more data or information that I'd like to extract from this, but the initial assessments do indicate that environmental DNA can detect a wide range of taxa in these sites. But as you saw from some of that initial data, that some of the sequences were not assigned to taxonomy. And so the reference sequence databases do need to be improved. Sensitive taxa were detected only at sites with higher CSCI scores, which is what we expected to find. And that dissimilarity increased with differences in CSCI score and also with distance, physical distance. I'd like to point out that this is not designed to replace traditional bioassessment methods, but could be a very helpful complement to those techniques. And of course, you can't get information from sequences such as the age of the organism that you're collecting or instar stage. You can't get information about behavior, or there's a lot of things that were limited with assessments with only looking at sequences. Also, the CSCI scores were obtained from swamp databases, and they were collected across different time points. So it's likely that those values have shifted based on season or year. So I'd like to point that out as a limitation. So this is an overview of molecular biomonitoring, which should, in my opinion, incorporate both sequencing as well as traditional bioassessment methods to both ground truth the sequence data that you're referencing, but also to gain those sorts of metadata that we can't get just from sequence data alone. And with that, I would like to say thank you for your time and attention and ask if anyone has questions.
Great, thank you so much, Sarah. And we do have question in the chat for you. So at sites with the lowest CSCI scores, you have slightly higher ASB richness. Do these represent novel taxa that aren't found at sites with higher scores, for example, more non-insects?
That's a great question. So I still need to do some of the beta diversity analyses for this data. It's possible that they do represent different taxa than what we're seeing in higher sites. And I'm very curious to learn more about what is actually in those sites and how that varies between CSCI score.
All right, and another question for you first, a comment, this is very cool work. And what's the estimated cost of sampling and sequencing eDNA samples for BMI taxa from start to finish?
That is a great question. And I have an Excel spreadsheet that itemizes all the costs for each step. However, my cost estimation may be slightly outdated because the technology is getting cheaper very rapidly. And when I initially made that spreadsheet, I think it was in 2019. So I'd have to double check to see what the cost is per sample. I feel like it was in the $50 range, but I could be way off, especially now that some time has passed and things are continuing to get cheap, less expensive. So the sequencing that I did at the UC Davis Genome Center was on a MySeq with 300 paired end sequencing. And when I ran it, it cost $1,700 to run all of my samples, although there are some additional costs with library prep and reagents for this kind of thing are a little pricey. So I'd be happy to share that if people want to reach out to me by email. Again, with the caveat that it's probably cheaper than what my original estimate is.
That's a good thing. Thanks, Sarah.
Yeah.
And then a few more questions for you. Let's see. So for river systems, how do you ensure that taxa being detected through eDNA are local to the sampling site and that the DNA source is not higher up in the watershed?
That is a great question and is a topic of discussion in the field for sure. So that was one of the reasons why I wanted to compare water filtrate with sediment, because the sediment samples should be more representative of the immediate community for a couple of reasons. One, that you don't have as much flow. So in the samples in the water column, DNA obtained from the water column is obviously moving with the current downstream. And so there are a number of really excellent papers looking at rivers as conveyor belts of DNA. And so that was one question I had. And I have a feeling that the higher number of family level detections from our water filtrate is representative of taxa that are upstream from the sampling site versus what we're seeing in the sediment, which is representative more of the immediate community. And some support for that was in our pilot study. We looked at how many subsamples of sediment we would need to collect per site to find macroinvertebrates, because as you may know from traditional sampling, they are really patchily distributed in their habitat. So that's why you do multiple transects, multiple kicks, is to find all the biodiversity from those samples. So we tried to replicate that in our sediment sampling approach. And we found that common taxa were detected among all subsamples, but that rare taxa were only representative in a subset of those. So we did 17 subsamples and we found rare taxa in 4 of those for some rare taxa. So it's a great question. I don't think we can rule out the fact that maybe some sequences are from other places. You may have a bird that defecates in the water and then you see some of what that bird was eating, for example. But you can also use things like ground truthing and doing accompanying kick netting to verify what you're seeing in your sequencing data.
Awesome, thank you. And let's see, we've got just about one more minute here, and there's a couple questions. So how about, can you talk a little bit about the library and what the methodology for establishing them is for aquatic species? And that
For
might
the
be an offline. I don't know if that's a short
Yeah,
answer.
I think the question is about the reference library,
Yeah.
not the library preparation. And the reference library, it's more than I can go into in 1 minute, but I'd be happy to answer that by email, and I'll put my email in the chat.
Okay, awesome. Thank you, Sarah. And there's another question, but we'll get those off to you so you can address them. And thank you again. That was an excellent talk. And I know we're ready to break here, but we do have some work, as you're aware, with the Swamp Bioassessment Program and using molecular methods in eDNA. We also have, at the end of the show, I've got a slide I'll share with everybody. One of our staff sites is working on a project with these like easy to deploy eDNA kits, and we're looking for partners. So I will get that slide up during our break, and please feel free to reach out for questions. We'll talk more to it later. With that, I don't want to eat too much into our break time. But let's go ahead and break, be back here at 10:35, and we have our third session of the day. Thanks, everybody. All right, hi everybody, and welcome back. It's 10:35, so we'll go ahead and get rolling again. I think I said we're going into session 3, and I traveled forward in time. We're only at session 2, so I'm going to go ahead and introduce our next moderator for this session, Chad Laughlin. Chad, are you on?
I'm on. Can you hear me and see me?
Yep. Hi. So Chad is a senior environmental scientist for the Regional Water Board in San Diego, and he oversees the water quality monitoring, assessment, and research program there in San Diego, including the region's surface water ambient monitoring program, or SWAMP. He's currently the project lead for the San Diego region on adoption of biological objectives for perennial and intermittent streams. And speaking from personal experience, Chad's an awesome coworker and colleague and has a wealth of knowledge, and hopefully will help advance statewide protection of our biological streams. So this next session, Chad, I'm going to hand off to you, and the floor is yours.
All right. Thanks, Allie. Like she said, my name is Chad Laughlin. I work down in the San Diego region, and I'm very excited about this session because it's all about temporary waters, which we have a lot of down here in San Diego. So the focus is really on intermittent and ephemeral streams today, or non-perennial and episodic streams, or really whatever you'd like to call them. But these are important water bodies. And I think today there's also going to be some vernal pools thrown in for good measure. So with that, let's kick it off with our first talk from Joe Morgan from US EPA. And just to introduce Joe, Joe Morgan is a life scientist with the wetlands section of US EPA in their Region 9 office in San Francisco. He coordinates Clean Water Act Section 404 permit reviews and jurisdictional assessments across the region, and is particularly focused on inland Northern California. He's also a project officer and technical contact for several EPA grants to state agencies and regional governments, including projects mapping Central Valley vernal pools and Delta aquatic resources. Joe lives in Oakland with his wife, Emily, and 13-month-old son, Finn. And his talk today is going to be about monitoring assessment tools that recognize the unique functions of California's temporary waters. So with that, take it away, Joe.
Thank you, Chad. I'm excited to be here today to talk to all of you about two in particular of EPA's recent efforts to improve monitoring and assessment in temporary waters. Before I start, I'd like to acknowledge that I'm joining you virtually from the traditional lands of the Lishan and other Chochenyo-speaking people of the eastern San Francisco Bay Area, who have stewarded these lands from time immemorial and continue to protect them today. During my presentation, I'll be discussing waters located on traditional indigenous lands across modern-day California, including vernal pools on the occupied lands of the Yokuts, Chukchansi, Miwok, Patwin, Nisenan, Nomlaki, Wintu, and Yana people. Many of you are already familiar with the Wetland and Riparian Area Monitoring Plan, or RAMP framework. RAMP was developed by the California Wetlands Monitoring Workgroup and describes a comprehensive plan for monitoring aquatic resources in a watershed context. Driving concerns are used to identify monitoring questions and objectives, which then determine data needs. Data is collected and interpreted, then assessed in reports and archived in publicly available online databases for further use. Finally, results are used to inform driving concerns, which starts the process all over again. RAMP uses EPA's level 1, 2, 3 framework to differentiate between different data collection methods. Level 1 data over here include geographic inventories of different aquatic resource types. And an example of this is the California Aquatic Resource Inventory, CARI, or the broader National Hydrography Dataset, NHD. Level 2 data include rapid assessment of ecosystem function or conditions. You may be familiar already with the California Rapid Assessment Method, or CRAM, which is commonly used in the state. Level 3 data require more intensive protocols, such as water quality analytes or bioassessment. In this presentation, I'll be focusing on how EPA is working to improve monitoring and assessment in temporary waters. Different people use different terms to describe these types of ecosystems, but the definition that I'm using here is temporary waters, which are aquatic ecosystems that do not support surface water year-round. These waters are very widely distributed, especially in arid regions like much of California. They function differently than their perennially wet cousins. Biogeochemical processes are often similar to both aquatic and terrestrial ecosystems, but are strongly influenced by hydroperiod and drying. Temporary waters also provide different kinds of ecosystem services. Importantly, rather than directly supporting human uses, temporary waters more often provide distributed ecosystem services that support the broader aquatic and terrestrial environment. Here are a couple of photos of temporary waters in California. First, a tributary of Deer Creek in southern Sacramento County. Here is Olcott Lake, a temporary playa lake in southern Solano County under very wet conditions in 2017. Here's the same Olcott Lake in our very dry 2021 water year, showing how widely the wetness of temporary waters can change over time. Temporary waters pose a number of important monitoring challenges for resource managers and regulators. Since they are so numerous in arid regions, their distribution is not well understood. They are not mapped to the same precision as quote unquote blue line streams. Even where they are mapped, little information is available on the hydroperiod of temporary waters. For example, NHD uses the F code attribute to assign streams as either perennial, intermittent, or ephemeral, but these classifications are often inaccurate. When temporary waters can be identified, level 2 assessment tools developed for perennial waters often do not accurately characterize ecological condition of temporary waters due to differences in functions and services that I described earlier. Similarly, little baseline and reference monitoring data is available for temporary waters. I'm going to dive into the first tool I want to discuss in this presentation, a new mapping approach for vernal pools in the Central Valley that I'm working on with EPA's Office of Research and Development. Since the 1970s, a core group of vernal pool ecologists have been evaluating the continued loss of vernal pool grasslands in the Central Valley, mostly from habitat conversion to irrigated agriculture. These methods use manual interpretation of aerial imagery to identify vernal pool complexes, not pools, and assign them to one of 5 cover classes. You see that in the table in the lower right: less than 2%, 2 to 5%, 5 to 10%, greater than 10%, and 100%. The acreage of each cover class lost is multiplied then by the midpoint of each cover class to give a very crude estimate of how many wetted acres of vernal pools were lost during the studying period. EPA recently funded a remapping effort that uses the same methods, and expect the results will be available in early 2022. At the same time, we're also looking into new potential methods to identify and track individual vernal pools in a way that could both validate the manual interpretation and provide additional remotely sensed information on vernal pool condition and function. The approach that we're looking at uses time series analysis of synthetic aperture radar, or SAR. Inundated areas have very low backscatter of SAR, allowing pools to be identified during the wet season. Furthermore, SAR backscatter can be plotted against time to identify a characteristic hydroperiod for a given pixel. For example, here, a pixel located within Olcott Lake at Jepson Prairie. Here are some preliminary results from 3 given water years at Jepson Prairie, which includes Olcott Lake, the large playa lake that I showed you earlier. Darker values represent areas that are inundated for longer. And this is the 2017-18 water year. Then the 18-19 water year, where you see that the entire lake was inundated, except for the berm running through it. And plus, we can also see pretty strong signals from most, but not all, vernal pools within the study area. during the much drier 1920 area, we can see that Olcott Lake is really functioning more as a number of individual pools than as a large playa lake. And then we have many smaller pools in the rest of the landscape that don't show any inundation at all. So we're hoping to bring in other data sets to complement that SAR time series and improve our model performance. In addition to hydroperiod, vegetation indices like NDVI can be tracked through green up and desiccation to differentiate vernal pools like this blue line here from irrigated agriculture, which greens up later in the season and stays green through the dry season. So moving on now, I'm going to switch gears and discuss another set of monitoring tools that we are developing for temporary streams, and those are streamflow duration assessment methods. Streamflow duration assessment methods, or SDMs, use physical, chemical, and biological indicators to predict the flow duration class of a given stream reach. So when I say flow duration class, I'm referring to either perennial streams that flow year-round, intermittent streams that are supported by base flow for portions of the year, but also dry out regularly, and then ephemeral streams that only flow in direct response to precipitation. SDMs are a rapid field-based assessment tool that can identify streamflow duration class for a specific study reach over a single site visit. We're hoping that SDMs can be used in a variety of settings to support jurisdictional determinations under the Clean Water Act or other statutes, to improve ecological assessment by providing accurate site-specific information on streamflow duration, to improve application of water quality standards for the same reasons, and to allow for prioritization of restoration and protection efforts in appropriate hydrologic settings. In March of this year, EPA and the US Army Corps of Engineers released a beta SDM for the Arid West ecoregion, which covers most of California except for the North Coast and Sierra Nevada mountains. The Arid West SDM uses only 5 indicators to identify streamflow duration class. Those 5 indicators are: 1, the number of hydrophytic plant species; 2, the number of aquatic macroinvertebrate individuals, and they can be living or dead; 3, the presence of EPT, Ephemeroptera, Plecoptera, or Trichoptera taxa, which are thought to be sensitive to drying; the presence and cover of algae; and the presence of fish, excluding mosquito fish. From these relatively simple parameters, a practitioner can rapidly determine whether the stream reach that they are assessing is perennial, intermittent, or ephemeral. I will also note that some combinations of parameters will give a result of at least intermittent, that means intermittent or perennial, or needs more information. The beta SDM for the Arid West includes a manual that describes the protocol in detail, including instructions for data collection, interpretation, and reference images for aquatic macroinvertebrates commonly found throughout the ecoregion. The beta method has been found to be over 80% accurate in distinguishing ephemeral streams from intermittent and perennial streams, but additional information may be needed to supplement SDM assessments if greater accuracy is desired. Thanks for sticking with me. Here are a couple of next steps / ongoing work for Central Valley vernal pools and streamflow duration assessment methods. For vernal pools, we're wrapping up the development of the automated mapping methodology that I described earlier, and we'll be using it to assess 3 pilot regions in the northern, central, and southern Central Valley. Under the same grant that is remapping using the manual methods, SFEI is also conducting a range-wide ambient assessment of vernal pool condition and also developing habitat development curves for restored vernal pool sites. We also funded a separate 2019 proposal that will use these findings with other information to develop landscape conservation strategies for 10 vernal pool ecoregions across the Central Valley and also the Modoc Plateau. We're about halfway through the 1-year beta period for the Arid West beta stream flow duration assessment method, and we're continuing to solicit feedback for the method. We're also preparing to release a beta method for the Western Mountains ecoregion that would cover the remainder of California, that is the North Coast and Sierra Nevada mountains. We're working with the California Wetlands Monitoring Workgroup to crosswalk SDAM with the California Aquatic Resources Inventory, CARI, and the California Rapid Assessment Method, CRAM, classifications, and to integrate SDAMs in level 2 assessments of condition. We're hoping that this will encourage wider use of the SDAM beyond just regulatory settings, especially in watershed scale assessments of stream flow duration. Last, I'd like to acknowledge the many contributors to this work. The SFEI team working on the vernal pool mapping and condition assessment products I described before, the EPA Office of Research and Development team that's developing the automated mapping methods I discussed. And then last but not least, the SDAM project delivery team, contractors, and regional steering committee that have been working on the Arid West and Western Mountains SDAMs. And with that, I will conclude and ask for any questions. Please feel free to contact me with any questions or feedback.
All right, thanks, Joe. Great talk. Let's see if we definitely have some time for some questions. Let's see, there is a question that came in. Basically, it says, in England, some mayfly and stonefly taxa have species indicative of temporary and perennial stream flow. Have you tried to identify indicator taxa, for example, within the EPT?
Yes, so I didn't really describe much about the SDAM development, but it used a very broad suite of parameters, including family level or lower taxonomic classifications of invertebrates at the data collection sites. I know that for SDAMs that have been developed for other parts of the country, such as the Pacific Northwest, and I believe New Mexico, that they have identified specific taxa within those EPT groups that are indicative of perennial or less than perennial flow conditions. Just for this particular SDAM, it turned out that the EPT classification worked as well as the other ones.
All right, thanks. We got a couple other questions coming in. The next one is regarding, I guess it looks like a kind of a regulatory implementation question. So it looks like the question is if industrial wells can pump a stream dry for hundreds of yards. So the question would be, what stream flow duration class would that stream then belong to?
Yeah, that's a great question. So SDAMs are developed to be independent of the particular mechanism for drying, whether it's due to base flow recession or the loss of snowpack, and presumably should work just as well for streams that are being dewatered by groundwater pumping. I'll note that we're in the preliminary stages of developing a SDAM for the Hawaiian Islands, where most non-perennial streams are go dry due to diversions rather than for natural reasons. I hope that addressed that question.
Thanks. And there's another question that's pretty similar. I think maybe you answered it, but I'll read it to see if you have anything to add. how do we assess if the SDAM is a good method for our system? Does it have to be a natural stream, or can it be hydromodified or moderately regulated flow channel?
Yeah, so in developing these, we really wanted to make sure that it worked as well for highly modified systems, as well as more pristine or less anthropogenically modified systems. So it should work just as well. I'll continue to note that this is a beta method, and we're continuing to collect data, including in hydromodified systems. So if you have any comments on the performance of the method in modified systems, I'd be very interested in hearing about it.
All right. Looks like we have another question that came in. Is or will the SAR data be made available to the public, and is it collected yearly?
Yeah, so we collected the SAR data under contract to a company called Planet Watchers, and our intent is to make that data available on at least on the EPA Geo platform, and then what we're also hoping to develop from this product, from this effort with Office of Research and Development, is essentially a product where you could plug in your own remotely sensed SAR data for a given area and identify vernal pools based on their SAR signature, along with any other parameters that we choose to include in the model.
All right, thanks. So that looks like that's about all the time we have for questions right now. There are some additional questions, but Joe, please feel free to answer those in the chat feature. And then we can move on to our next speaker.
Thank you so much for your time.
All right, so our next speaker is Adam Price. He is a PhD candidate at the University of California at Santa Cruz, and his research focuses on the insights and applications of machine learning and artificial intelligence on emerging hydro and hydrogeological issues. His research specifically includes applying these methods to intermittent streams and rivers. And so today, the title of his talk is The Drying Regimes of Non-Perennial Rivers and Streams.
Wonderful, thank you. Is my cursor showing up on the screen here as moving? Maybe.
I am not seeing your cursor.
I am able to change slides. No problem. I guess I'll just have to describe very well. Well, thanks for inviting me. It's really nice to see a bunch of familiar faces here, as well as some new faces. So thanks for having me today. Like Chad said, I'll be presenting my work on the drying regimes of non-perennial rivers and streams. This is work that I've done with my co-authors, Nate Jones at the University of Alabama, John Hammond at the USGS, Margaret Zimmer also at Santa Cruz, and Sam Zipper at the Kansas Geological Survey. This is kind of under the umbrella of the Dry Rivers Research Coordination Network, and we've been able to have a bunch of good conversation that this work was born out of. Also, this was recently published in GRL. So if you have any questions about this that you don't want to email me about, the paper is out there to take a look at. So to get started here, I'm gonna plant this seed or start with this idea that, you know, the aquatic sciences have this long tradition of connecting hydrologic variability to ecosystem function, characterizing ecologically important components of the flow regime. And so this diagram here on the left is from POF 97, where they introduced the flow regime concept, which is built around the timing, duration, frequency, magnitude, and rate of change of flow to classify the natural flow regime. And these unique functions of the flow regime are due to the occurrence of the flowing and the dry states, yet most of our scientific and management frameworks are built around perennial stream flow. And so while the flow regime paradigm is important for loadic systems, there's a need to extend this perspective to non-perennial rivers. And so I feel like you just saw this slide or this graphic in the last talk, but when I say non-perennial, just to clarify for everybody, I mean rivers and streams that do not have continuous flow throughout the year. And these systems comprise a majority of global river networks. And then if you see this figure here, most of, contiguous US river networks as well. And these are predicted to increase in extent due to continuing human alterations and climate change. And across spatial scales, non-perennial rivers play an important role in material storage, downstream transport, habitat partitioning for riparian areas and aquatic ecosystem, as well as the biogeochemical processing of carbon. So in order to connect the river drying to the physical, chemical, and biological functioning of a stream, there's need to understand not just whether a river or stream dries, but the characteristics of how it dries and how distinct or dissimilar the characteristics of drying are across watersheds with different climates, physiographies, and land cover. And so without this information, our ability directly to compare ecosystem conditions and functions, as well as management strategies between river and stream networks, is fairly limited. So in this study, we complement the flow regime concept that I introduced in the first slide by presenting a hydrological framework for the drying regime here on the right-hand side, which focuses on the timing, duration, frequency, and magnitude and rate of change of drying in terms of drying. So focusing on the hydrologic signatures of drying extends the flow regime's paradigm into relatively uncharted waters, pun intended, of non-perennial streams and rivers and their ecosystem functions. And furthermore, we recognize that drying is a complex hydrologic process that impacts ecological, chemical, and physical characteristics of river and stream systems across CONUS. So the questions that I'm going to try to answer today, or that our study aims to answer, are there a contiguous scale, contiguous US pattern scale, that indicate the presence of distinct drying regimes? And then how do these drying regimes vary both in space and in time? And then the last question are what climate and watershed characteristics are most important in determining a drying regime? So in order to formulate this framework, we first needed to define a drying event. In our study, we defined a drying event as an antecedent peak directly preceding a zero or a no flow event, all the way through that no flow duration until we see the reemergence of flow. So now that we have this drying event, we're able to calculate these hydrologic signatures of drying. So we have the value of our antecedent peak quantile. We have a bunch of timing metrics with the drying event start, the dry date start, which is where you have no flow, and then a drying event end where we have that reemergence of flow. You also have some timing aspects here with the length of the dry down duration, the no flow duration, but then we're getting at this rate of change with the drying rate. So how fast, or what the rate of change is from that antecedent peak to that 0 point. And so the data set that we used was the USGS Gauges 2 data set, where we isolated 25,207 of these unique drying events. Our time period was from 1979 to 2016, and we utilized 894 USGS stream gauges. Unfortunately, the spatial distribution of these gauges didn't come up here, but there is a pretty wide and distributed spatial distribution of gauges where we have reference and non-reference gauges. And so, these reference gauges we're considering as minimally impacted gauges, and then the non-reference gauges being the opposite of that. Additionally, for our kind of spatial grouping in this study, we use the EPA level 1 ecoregions that are kind of distributed across CONUS. And so using these hydrologic signatures of drying, we use clustering to try to group these into drying regimes. And so the plot on the right-hand side is the principal component plot, and then the points are colored by the clusters that we got from our cadence clustering as a function of what those cluster numbers were. Throughout the this point, the rest of the talk, I'll use clusters and drying regimes interchangeably. But anyway, we use k-means clustering, and we used 4 hydrologic signatures of drying. So we use dry down duration, which is the duration and rate of drying in our kind of conceptual framework. Our no flow duration, so that would be a duration in our framework. Antecedent peak quantile, which would be a magnitude, and then a drying rate, which is the rate of change of flow. If we look at how these clusters group, You can see here on the right-hand side, a simple bar plot that is our hydrologic signatures of drying as a function of cluster membership. And I'll actually just walk through these pretty briefly here. So our cluster number one, or drying regime number one, we're quantifying as quantifying as our flashy cluster, and these would be kind of ephemeral streams that we're imagining. It's about 18% of all of our events, very flashy drying events, that was characterized by a very rapid drying rate that you can see here on this upper right plot. A very short dry down duration, which is that upper left plot, and the very short no flow duration, which is the lower left plot here. Examples of these streams would be streams with minimal groundwater sources or experience very flashy flow events. Our next cluster here is our long no flow duration cluster, so intermittent streams that have this kind of seasonal component to them. 4% of all events fell into this cluster. It was a very rare drying event that happened. They had a very long dry down, very long no flow duration, and so that long no flow duration is there in the bottom left plot. Examples of these streams would be streams in Mediterranean climates, so a strong seasonal input or a very large storage component. Our cluster number three was our low peak quantile cluster, and so these would be our intermittent groundwater type streams. 39% of all events fell. 39% of all events fell into this cluster, and about 91% of gauges had an event in this cluster. This was mostly characterized by this low peak quantile, which is very striking in this bottom right plot here, a shorter no flow duration and a long dry down duration. And examples are streams where groundwater slows drying. And then our last cluster here, I like to term as the average Jane Joe cluster. This would be the intermittent flashy streams. And so a very similarly common cluster where 39% of all events fell into this regime or cluster, and about 75% of all gauges. And what's defining about this cluster is it's defined by the median behavior across all of these different hydrologic signatures of drying. Examples of this cluster would be streams with frequent input but disconnect fairly quickly. And so to kind of look at we see that all of these clusters group into these four coherent groups, but what does that look like temporally? And what we see is these clusters exhibit substantial temporal variability. And so if we look at the plot here on the right, the upper plot is the number of drying events as a function of month throughout the year. And then the bottom plot is a proportion of drying events as a function of month throughout the year. And so as we see here in this upper plot, that most events occurred during the summer independent of clustering. We'll kind of walk through where the different clusters kind of fell out temporally here. So cluster one was pretty constant, but had an increase in September to October. Cluster two, pretty constant, but had that kind of late season, November to December increase in number of drying events. Cluster three has had very high seasonality with about 40% of all events occurring from the June to August range. And then in the lower cluster, you can see that the proportion of events is dominated by cluster three in those summertime, in that summertime period. And then cluster four additionally had very high seasonality, but that had that earlier peak in that May to June time period. And so these clusters, interestingly, lacked regional coherence. This plot here is a map of the CONUS US, faceted by the different cluster membership, and then the alpha, or the kind of transparency of the dots, is the proportion of events that fall into that cluster. And so the fact that the clusters lacked regional coherence in this at the event scale drying regime is kind of a novel finding in itself that contrasts with a lot of other work with no flow studies that found that there were strong regional patterns around the mean annual timing and the annual fraction of no flow. And so climate is a primary driver, which are these colors in the background here, though our spatial results highlight that the localized conditions appear to impact drying characteristics at the event scale. And so this limited regional coherence of the clusters indicate a larger role of the local physiographic and land cover characteristics that influence the hydrologic signatures of drying that we honestly didn't expect. And so in order to get at what's actually driving the cluster membership, we have this huge data set from the Gauges 2 data set, and we performed some random forest analyses to determine what actually determines the cluster membership. And so a very simple explanation of a random forest approach is you have if you look at this figure here on the right, you have some random subsample of data. You have some predictor variable and you say, is there a value below this? Is there value above this? You kind of have a threshold there. Then you then split your data based on those thresholds. And then, you know, one kind of leaf of your tree is determined by the dominant cluster that falls into that leaf. And then you continue splitting that all the way down until you have this kind of nice decision tree, so to speak. And so this is completed multiple times to determine the most important predictor variable. You then tabulate how important that predictor variable is, and you're able to tell about what the relative importance of these predictor variables are in your simulations. And so our approach was to build one hypertuned classification random forest model where our response variable was our cluster membership, 1, 2, 3, or 4. And then our predictor variables were land and water use and watershed characteristics. What we found from our analysis was that land and water use were 5 of the top 10 predictors. And so this plot here on the right is variable importance. And as a function of predictor variable, essentially the higher the value, the more useful it was in accurately predicting cluster membership. And so what we see is land and water use are 5 out of the top 10 predictors. Climate were 4 of the lowest 8 predictors, and clusters 1 and 2 with those very rare events were very difficult to predict. And so kind of to wrap up these questions that I posed in the beginning, are there these kind of CONUS scale patterns that indicate the presence of distinct drying events? And we show that our results show that the drying events lack this spatial coherence, and this general lack of the regional coherence is a novel finding. But despite the wide variability in drying behavior, we were able to clump these or group these drying events into 4 distinct clusters. And this application of this conceptual framework across CONUS highlights the complexity of the interplay between the event scale characteristics and the watershed properties that together control the drying patterns of non-perennial streams. And the second question is, how do drying regimes vary in time and space? We found that the USGS gauges in the study experienced drying events belonging to multiple drying regimes throughout the record, suggesting that dominant drying mechanisms and drivers within watersheds actually change throughout time. We do note that gauges are point scale measurements, and so they're aggregating all of this kind of heterogeneity and connectivity within a watershed that we're actually observing at the gauge scale. And then finally, what climate and watershed characteristics are most important in determining a drying regime? You know, we saw that land and water use, storage and topography, so all these physiographic characteristics were most important in determining what was happening with the drying regime. And so these drivers of the drying regimes are not only linked to the specific land use cover and categories, but also to the resulting behavior or mechanism responsible for altering flow within these systems. The combination of these kind of act like a template, which then climate acts upon to determine the eventual drying regimes. This result was very surprising to us, but it kind of illustrates the power of these data-driven approaches to pull out these interesting relationships within hydrology. And with the limited time I have left, I'm just going to kind of run through these last couple slides. And we just think that this drying regime framework could be used to understand the range of drying characteristics in time and in space, examine how these drying characteristics change throughout time, could change in the future. It also enhances our understanding of how internal watershed properties store and release water to drive this annual variability in stream drying. Also, it could be used to link these ecological and biological parameters with drying regimes. And then we could also maybe use it, or it could be used to fine-tune ecosystem and water resource management practices. And so this study the drying regimes to ecological functions. And my call to this community is, do you have an answer how we can connect these drying, these hydrologic signatures of drying to ecological, chemical, or biological relevance in these different systems? And what might these connections be? And so with that, I would say, use our data. This is publicly available data that's up on Quasi-HydroShare. So I would encourage you to look at that, but also would love to make any kind of collaborations to kind of take this work a little more out of the hydrosphere into the ecosphere and all the other spheres. So anyway, with that, I will wrap up. Thank you so much.
All right, thank you, Adam, for that great talk. Reminder to put your questions in the Q&A, and looks like we have a couple questions coming in. First one is actually one that I was going to ask myself if it wasn't asked. Given the scarcity of gauged ephemeral streams in the U.S. Gauge network, how might this bias affect your classifications? So, like, are you missing any types of drying events? And what would be the best way to address this bias?
Yeah, so I think I'll start with the end of Raphael's question first. The best way to address this bias would be more gauging. That would be that would be wonderful. Yeah, I'm going to stray away from directly saying that we have bias in here and saying that yes, there is this kind of preferential gaugings of these ephemeral streams. So yeah, we do have a little bit of bias. We may have a little bit of bias in the data, but we can only correct for that if we have more data. And so we were kind of used what we had, and we identified that within our paper that says like, okay, this is actually skewed a little more towards this, but that's the data we had to work with. So
thanks. There is another question. Before I get to that, I would just ask a follow-up question along those lines. Be a little selfish on my part. So given that question, if the USGS basically said, hey, Adam, we're going to hire you tomorrow and give you a huge boatload of money to put in gauge systems in California, what would your priorities be based on like stream types, geographic areas? What would you consider?
Yeah, not to kind of punt that question, but I think that what actually needs to happen is we need to kind of focus on gauging those areas that are the most important to the community as a whole. As a hydrologist, I'm like, yeah, let's, do kind of a representative sample, but I think we really need to focus on these areas that do go dry. I mean, we are seeing an increase of non-perennial streams across the US and particularly in California, but where those systems are going to be heavily impacted. And if we can connect this framework to, the broader community as a whole, I think we can actually, target where we put those stream gauges. So I would say that would be my answer, is to try to connect it to the community as a whole, and then maybe we could figure out where those gauges would go. So.
All right, next question that came in is, why would you expect a site's drying regime to change seasonally? Wouldn't you want a drying or flow regime to represent annual variation?
Yeah, so the first part of the question is why would you expect it to change seasonally? And so what we think is happening is this land cover, kind of the physiography of the watershed is this template that the climate acts upon. And so what we actually think is happening is some of the seasonality with the climate is actually acting upon those watershed characteristics. And so the differences in, your climate at the different times of the year, so you're actually giving you these different drying events. But what's actually important in defining those is kind of those watershed characteristics. Great question, though.
All right, and it looks like we have one more question, which we do have time for. And this one is kind of linking it to forest management. So the question is, Stephen Brantley of the Jones Center replaced commercial loblolly and slash pines with longleaf pines in a third of a watershed and got a 9% increase in water yields. So the question is, how many clusters are anthropogenically driven, and would something like prescribed fire change those clustering or those clusters?
Yeah, that's an interesting question. To kind of answer the first part of that about anthropogenically driven. We did do some statistical tests to test the distributions between the clusters of a reference and a non-reference gauge, and we didn't find any statistical differences there. I do think that points to a larger problem of reference versus non-reference gauges, and are they really representative systems? And so that's my answer, at least in this study here. And I don't know how prescribed fire would change the clusters. That would be something super interesting to parse out, is really hone in on some of these systems that have been affected by fire and see how the drying regimes change. So I don't have an answer, but I do have an interest. So that's what I have there.
All right, thanks, Adam. Looks like that's the last question we can take in terms of time. And I don't see any other questions in the Q&A to answer offline at this point, but feel free to ask more questions of Adam.
Thank you.
Thank you. All right, so our third speaker and last speaker for this session is Katie Irving from the Southern California Coastal Water Research Project, or SCWRP. Katie is a scientist specializing in the relationship between the distribution of river species and their environment. Her doctoral degree dealt with the role of hydrology in species distribution models, SDMs, on benthic macroinvertebrates. This work involved developing SDM methodology by creating a hydrologic data set, optimizing variable selection, and testing the performance of existing hydrologic data sets. Her current research with SCWRP is focusing on the effects of hydrologic alteration through the development of flow ecology models, aiming to conserve the health of Californian streams. Katie received her doctoral degree from Berlin's Leibniz Institute for Freshwater Ecology and Inland Fisheries, her Master's of Science degree in Freshwater and Marine Ecology from Queen Mary University of London, and her bachelor's in marine biology from the University of Plymouth. And her talk today is on establishing flow targets for management through flow ecology analysis, a functional flow ecology approach.
Hi there. Yeah, thanks, Chad. Just want to check you can hear me and everything first. And I do want to point out that the title actually changed, so I apologize for that. But yeah, thank you everyone for coming and listening to the talks today. I'm going to talk about our application of flow ecology analysis for prioritization. So just a little bit of background. We're all very aware that flow alteration is a pervasive issue around California, and that does impact biological condition. But in order to manage for flow alteration, we need to really understand the level and pattern of alteration and how that actually affects biological communities. That knowledge is going to help us with prioritizing locations if we want to do restoration or flow management activities in those areas. So this study is actually part of a wider study with the overall objective to develop tools and data sets to inform management decisions. This particular study is looking at how to evaluate biological alteration for prioritization, and we do that through flow ecology analysis. Just to be explicit, what I mean by biological alteration is where flow alteration is impacting biology. So you'll hear that term a lot in the next sort of 15 minutes. So basically through flow ecology analysis, there are many decisions to make, there are many things to consider. So we've set up this kind of process that observes certain criteria to try and get the best out of a flow ecology analysis. So those criteria basically aim to protect multiple biological assemblages. So not just focusing on one, because focusing on one may compromise another. We also only want to make sure that areas aren't misclassified. Perhaps there's This seems to have a mind of its own. I don't know if it's delay on my side, but I'll carry on. So yeah, we don't want to misclassify an area as low priority if it should be high priority, for example. Also, we want to make sure we're using the most relevant seasonal flow components. And also something very important, we need to make sure that our analysis has an appropriate level of sensitivity. So we wanted to be able to discriminate locations to be able to prioritize them, because if the analysis is too sensitive, then everything is going to be altered. And if it's not sensitive enough, then everything will be unaltered, which doesn't help in our prioritization. So our study area is South Orange County Watershed Management Area. It's highly urbanized in a lot of the area. So there's a lot of irrigation and urban flows. So the work is actually conducted as part of the water quality improvement plan that's set out in the area. And the altered flow and erosion caused by that altered flow is one of the most the highest priorities. So we're looking at the areas in red. But the areas that are grayed out, they already have flow management in place, so we didn't evaluate those. So our ecology analysis has 3 tiers. I'm not going to talk about all of them today. I'm just going to talk about the middle one. So that's the biologic alteration based on CSCI and ASCII, and talk through how we determine biological alteration and observing our process criteria. So we use CSCI and ASCII. I'm pretty sure you guys know or have heard of these 2 indices before. So one based on bugs, one based on ASCII. And they're really useful for this type of analysis because they can differentiate between reference and altered sites. In terms of the flow, we're using functional flow metrics. So 5 functional flow components have been outlined for California. And they describe seasonal flow components such as fall pulse flow, wet season base flow and peak flow, spring recession, and dry season base flow. And within those components, there are individual metrics that describe magnitude, timing, duration, frequency, and rate of change of these seasonal flow events. So overall, how we built the flow ecology relationship is we gathered CSCI and ASCII bioassessment data from Southern California and modeled that with a delta H of each of the functional flow metrics. So the bioassessment sites are the black dots in the map there, and our study area is there in blue. And just to point out as well, the delta H is actually the change in flow metric from reference to current conditions. So we first performed boosted regression trees, and that was to look at how important each of the flow metrics were for the indices. And then the flow ecology analysis itself was done through logistic regression. And that was to predict healthy scores and assess the strength of the relationship. From that analysis, we're able to get delta H limits. And that's what we projected into the study area. So the first kind of main job was to find the most relevant or most important seasonal flow components or seasonal metrics. And we had this kind of filtering process that we went through to decide on that. So first of all, we kept the most important metrics from the boosted regression trees. We also made sure that we removed variables that were highly correlated. We also want to make sure that there was enough data density, so relationships weren't driven by 1 or 2 data points. And we wanted to make sure we use metrics that can actually be influenced through management actions. So this is what the relative importance looks like from the boosted regression trees. So each of these bars represents an individual metric, and the colors correspond to the flow components. So we found that peak flow, the one in green, was the most important for both CSCI and ASCII, but also spring recession in blue and wet and dry season base flow were also very important. So going through that process, we kept 3 variables for 3 flow metrics for ASCII and CSCI. So the magnitude of largest storm was important for both. So that was kept for both. That was the peak flow, the green bar in the last slide. And for ASCII, we kept dry and wet season base flow. And for CSCI, we chose spring recession and wet season base flow durations. So these ones, we only did the flow ecology on focusing on these particular metrics. And this is what the flow ecology relationship looks like. So this is an example of spring recession duration for CSCI. So on the y-axis, we have probability of achieving a good CSCI score. And then on the x-axis, we have the delta H. And because this is duration, it's measured in days. So here we have our, the first thing, I'm going to talk you through an example. So the first thing we have to decide on is what probability we want to use. Basically, we can use anything between 0 and 1. For this example, I'm going to show 0.5. So where that 0.5 probability line hits the curve is basically where our delta H limits will be. So, so anywhere between within that those limits are biologically unaltered, and then outside of those limits is biologically altered. So for example, if you had a site that was 25 days shorter than reference, then that site would be still unaltered. But if it was 50 days longer, it would be biological altered. So this example is based on the commonly used 0.79 index threshold, as well as the 50% probability threshold, as I mentioned. But there actually are a lot of other options that we can use, and this is where our sensitivity analysis comes in, of choosing the most appropriate kind of thresholds. So both CSCI and ASCII have 3 different index thresholds. So they correspond to likely altered, possibly altered, likely intact. So we're going to use each one of those with a combination of probability, and for this to kind of keep it simple and to get a good range, we chose these 3, the 0.25, 0.5, and 0.75. We used combination of those and tested how that impacts biological alteration. Something else we'd also needed to consider was the alteration over space and time, which basically means how many years within the period of record are within those thresholds, and how many subbasins are deemed as altered as well. So I'm going to run through this example. This is basically the exact same figure before, the spring recession for CSCI, but has the 3 different CSCI thresholds included. So you can already get to see how kind of different those are, as well as we do have our 50% probability threshold, as well as 0.25 and 0.75 that we want to test as well. So if we chose, for example, the most kind of stringent CSCI threshold, so 0.92 and 0.75 probability, our delta H limits will be 12 days longer. But if we chose a more kind of lenient option, which would be 0.63 CSCI threshold with 0.25, the delta H limit will be 70 days longer. So there's a huge difference between these 2 thresholds. So looking at that spatially, this is the study area divided up into different subbasins, and has all of the 9 combinations. So we would, if we look here, we can see, the alteration is the percent alteration over time. So the more yellow is basically the less alteration, and the more dark blue is the more alteration within the study area. So if we look at the most lenient option again, I don't know if you can see my cursor, that would be up here. So we're looking at kind of much lower alteration than, for example, the more conservative option, which is down here, which is much more dark blue. But for us, we want to look at prioritization. We want to be able to discriminate. Those 2 examples aren't actually that helpful for us, because we want to make sure we have something in the middle. We need a middle area. So what we can do is look at the percent of altered subbasins and plot that over time, and that's what you can see here. So each different line is a different combination of probability and the CSCI threshold. And as we want middle ground, we want combinations that are between 40 to 60% altered. And by this figure, it looks like we have 3 combinations in the gray box in the middle there that pretty much get there. And looking at those spatially again, we can see there's actually not much difference between those. So it's very similar. So we were able to discriminate between subbasins. We could basically use any of these combinations for our biological alteration analysis. So to get a final combination for each index, we repeated that process for each flow metric, and just chose the combination that was consistent between those metrics. And this is what we ended up with, and this is what we applied into the study area. So then we had to actually determine biological alteration. So for each metric, that was deemed altered if the delta H falls outside the limits, and unaltered if it was within those limits, like I showed on the figure. And then the individual subbasin was classed as likely altered if 2 of the flow metrics were altered for 50% of the years. So that gave us prioritization map for CSCI and ASCII. So the likely altered is there in red, and you can already see kind of differences between CSCI and ASCII. For example, this is Aliso Creek up here. It's a lot more altered for ASCII than for CSCI. So then we actually want to synthesize the indices here, because we want to make sure that we're looking at both. So for each subbasin, we classed a high priority if both indices were altered, then medium priority if only one index was altered, and then low priority if neither were. And that's when we get this map here. So this is the final prioritization. So we have 11 subbasins that were classed as high priority, 25 were classed as low priority. And then what is interesting is 24 were classed as medium priority. And these are they're pretty important ones, and because these are the ones that could have potentially been missed if we only focused in on one biological group. They could have been either ignored, or they could have been classed as a high priority if that was the way in the individual prioritization. So just to sum all of that up, I outlined a process at the very beginning of the talk, and we have observed that criteria by applying analysis on 2 biological groups, also applying a flowmetric filtering process. So we made sure that we're only using the most relevant seasonal flow components. And also something very important is comparing the different thresholds that we can use actually can vastly change the amount of alteration within the study area. And I just wanted to add in that this can be applied in other regions throughout California. We obviously focused in on a very small part in Southern California. But we have such a wealth of bioassessment data. This could be applied anywhere. It's also, we have looked at this through a statewide analysis led by Ryan Peake, which using observed data. And it can also be used as a component of, say, the California Environmental Flows Framework. Yeah, that's everything from me. Sorry about the technical issues, but I hope you could follow along okay.
All right, thanks, Katie. Let's see, if you have any questions, please go ahead and put them in the Q&A. We do have plenty of time for questions. It looks like we have one question that's come in so far. Can you please put a citation in the chat for this work? So people can digest it. So
yeah,
that's a pretty easy thing to do.
Yeah. The actual paper for this is in review, so it may have to wait, but I can send some information over.
All right, no other questions coming in. So if there are no other questions, then I think I will turn it back over to Allie to talk about what's coming up next. Oh, we did have one more question that just come in.
Okay.
And I think we have time for it real quick. Are there any dams or channelization effects on the study area?
Yeah, I mean, it's not, there's not so much damming as the main kind of issue with flow alteration comes from urban flows. So a lot of effluent, there's a lot of channel erosion, and the channels are kind of being incised rather than actual damming activities.
All right, thank you, Katie.
Great, thanks, Katie and Chad. I don't see any other questions in the chat. So at this point, let's see, a little bit early, but I don't think there's any complaints for a longer lunch break. Please be back here at 1 o'clock. I did want to mention that the CalSFS business meeting is happening at 11:45. If you go to the agenda, and it'll also be in the chat, I believe, there's a separate Zoom link for the CalSFS meeting. And there's Angela. Go for it. You probably have more to say about it. I just want to quickly mention after that meeting, you'll have to rejoin using this Zoom link to come back to the CABW meeting. Angela, do you have more to add?
I mean, you covered it very well, Ali. Thank you. John Olson is over there in the Zoom link right now in the Zoom meeting for the CalSFS business meeting. If you're interested in joining CalSFS or want to see what we've done this year, what we plan to do next year, come on over to the business meeting and we'll be able to talk about that. We're also going to have a brainstorming session. So if there's anything that members want out of CalSFS for next year, go ahead and join the meeting and give us that information, and we're going to keep track of it so we can work on that and add it to our goals and objectives for the next year. And yeah, so thank you so much, Ali. That was pretty much it. And just, yeah, remember you got to use the link that's in the chat right now for the CalSFS business meeting to take you out of this one. And then you'll have to rejoin after lunch. And I think we're going to keep the business meeting to about 20 minutes, half an hour. So feel free, you can eat, you can drink, whatever you want during that. And then there'll still be time to have a little break before CABW starts again. And then don't forget, today we have the poster session that starts at 2. And that is also another separate Zoom link. So you'll be leaving to go into different Zoom rooms. It's like our virtual live poster session. And we have 9 great posters from CalSFS students in there. So just keep that in mind for the rest of the day. And I think that is it. Yeah, well, John's over there now, so we'll start probably around 11:45, just make sure everybody can have their breaks and get whatever they need for lunch and join us over there.
Awesome. Thanks, Angela. And thanks, everybody. We'll see you back here at 1 o'clock. Just testing closed captioning. Test, test. Looking good.
Testing, testing.
Oh, wait, it's,
You can
I won't be
hear.
able to hear because my volume's off.
Try again, Shuka. Well, I see the subtitles. They're not great, but they're there.
Testing echo.
Confirmed.
All right, welcome back, everybody. It's 1 o'clock, and we're gonna go ahead and get rolling into session number 3. This is the last session of the day before the CalSFS poster talks. And I'm gonna hand it off to Shuka Rastegarpur, but first wanted to introduce Shuka. Shuka is an environmental scientist for the State Water Board, and she works in the statewide swamp program. She received her Bachelor of Science degree in Environmental Studies at California State University, Sacramento, and has nearly 10 years of experience at the State Board working on a number of things, including ocean water quality policy, industrial stormwater permitting, and she's currently the statewide coordinator for the statewide bioassessment monitoring program. And before I hand off to Shuka, I don't know if you all are aware, but she is also the mastermind behind the scenes for CABW and has done an excellent job at getting everything together for this 2-day event. And thank you, Shuka. I can't express enough gratitude for that. And with that, I'm handing it off to you.
Thank you, Ali. I wanted to express everyone who has helped out put this event together. Just much thanks. Like it's been, it's a lot more difficult to set things up over Zoom, but hopefully we'll all be together in person next year. So I'm going to present our speakers for this session. First up is Chad Laughlin. So Chad is he works as a senior environmental scientist for the state of California Water Quality Control Board, San Diego region. Chad oversees the water quality monitoring, assessment, and research program at the San Diego Regional Board, including the region's surface water ambient monitoring program. Chad is currently the project lead for the San Diego region on adoption of biological objectives for perennial and intermittent streams. So with that, Chad, I'm going to give things off to you.
All right, thank you, Shuka. Let's see if I can get things rolling here. There we go. All right, so today I'm very happy to talk to everyone about our efforts in the San Diego region on biological objectives. And so I work for the San Diego Regional Board. You can kind of see our area in the logo in the lower left-hand corner. I oversee our monitoring, assessment, and research unit, and our coverage area of the state includes San Diego County and portions of southwestern Riverside and southern Orange County, the coastal draining watersheds. All right, so our efforts on biological objectives really kind of predate 2013, being involved in a lot of bioassessment and whatnot. But in terms of the actual objectives themselves, it really kicked things off in 2013 as our regional board adopted a practical vision. And that practical vision specifically called out a couple of things for the board moving forward. One is to use latest science when taking actions, and also for prioritizing actions, and really also to focus on environmental outcomes. And for those environmental outcomes, they actually specifically called out biological measures for ecosystems. So this really is, I guess, my presentation in one slide. So hopefully you'll listen after this one. But essentially, this is kind of a time frame for Clean Water Act up to our adoption, our regional board's adoption of biological objectives. So, back in 1972, the Clean Water Act was adopted, and literally the first line of the act says that the objective is to restore and maintain the chemical, physical, and biological integrity of the nation's waters. And up until the 1990s, most of that focus was really on chemistry-based regulation and technology-based regulation, controlling those types of sources and getting the technology in place to do so. And really the focus on chemistry was a natural first step for the Clean Water Act, but the modern Clean Water Act has really become a technology-based, chemically controlled pollutant law, and that was really never the intent. So in the early 1990s, US EPA started encouraging the states to adopt the biological objectives. And in response, the state of California really ramped up its biological assessment program, its bioassessment program within the early 90s, or mid 90s, early to mid 90s. And Region 9 started doing a lot of bioassessment as well. That bioassessment led to the development of a lot of regional indices of biotic integrity in the early and mid 2000s. There was a SoCal IBI, there was a Eastern Sierra IBI, and a hydropower IBI. And so all of those IBIs basically led to the need for a standardized IBI that would apply statewide. So, work was starting on that. And in 2016, we had our basin plan triennial review, which looks at potential new projects for our basin plan, and biological objectives was identified as a priority project. That's because at the same time, 2016, the new IBI, the California Stream Condition Index, or CSCI, as people have talked about before, was scientifically published. And so from that time period up, we'd been working on biological objectives, and the regional board, San Diego Regional Board, adopted the CSCI as an objective in December of 2020. So I don't expect everyone here is familiar with biological objectives or the regulatory process and how things work. So I thought I'd start out pretty simple from the beginning. From a Clean Water Act, really regulatory perspective, what we're talking about is water quality standards. And those are found in each region's regional boards and basin plan. And so water quality standards are where biological objectives fit in, and water quality standards themselves are actually made up of two things. They're basically beneficial uses for water bodies, and then water quality objectives themselves, so criteria. And I'll talk about those real quick for context. So beneficial uses it really comes out of the public trust doctrine. They're basically uses of water that need to be protected from a water quality perspective. And there's a variety of types of beneficial uses, including biological beneficial uses. And biological beneficial uses really focus on ecosystem integrity, that biological integrity, and they apply for a wide variety of water bodies in our region. Some examples shown here is intermittent stream, coastal wetlands, and then rocky subtidal kelp forest. There's also other beneficial uses that we protect with objectives related to things like drinking water, human water contact recreation, so swimming, surfing, scuba diving, that kind of thing, and fish and shellfish consumption. So to protect these beneficial uses, we have water quality objectives, and these are actually the criteria, narrative or numeric criteria, that really focuses on specific pollutants, both in the water column and also for sediment, and looking at water column and sediment chemistry and toxicity. And also the same thing for sediment, looking at toxicity and chemistry. However, there's really two main issues with using water quality objectives focused in this manner. And one is they're an indirect measurement of the beneficial use attainment for these biological beneficial uses. And two, there's issues with accuracy, things like when do you sample, what pollutants do you actually sample for, are the thresholds really appropriate or not? And so it's really been known for quite a while that biological beneficial uses need biological water quality objectives. And that's really because the organisms living in the environment are an excellent indicator of biological integrity and that beneficial use attainment. And like I said earlier, US EPA identified this as a priority in the early 90s. And so where we are across the United States is 38 states, including California's neighbors, Arizona and Oregon, have biological objectives. Some other regional boards have narrative forms of biological objectives. And I should also mention that back in 2003, the state of California and US EPA actually had entered into an MOU whose one of the major goals of which was to get biological objectives adopted for California. So really, how do you get a biological water quality objective put into our basin plan? Well, you have to do a basin plan amendment, and there are a number of legal requirements for that we have gone through or are going through. There's requirements under the California Water Code. There has to be a scientific peer review done, a SQL equivalency done, a review from the State Office of Administrative Law, and submittal to US EPA. There's also quite a bit of public participation that is required. So where we stand right now is Basin Plan Amendment was adopted by the San Diego Regional Board back in December of 2020, December 8th specifically. It included 3 components: narrative guidance for developing future biological objectives, which I'll touch on a little bit later, an actual numeric biological objectives for streams using the California Stream Condition Index, CSCI, and also a program of implementation, basically how the biological objectives will be implemented in the various regulatory and non-regulatory programs the regional board oversees. So why did we choose the CSCI, or California Stream Condition Index? We chose it because it's a standardized reference-based index. It's standardized for the entire state and our entire region. And it's also grounded in reference, scientifically defined reference. The 2 citations are here. Basically, the CSCI is an index of biotic integrity that uses benthic macroinvertebrates. I think a lot of the speakers have covered that so far. If you're acronym centric, you could say the CSCI is an IBI that uses BMI. But we really picked it because of the level of scientific rigor that went behind the CSCI's development, and also defining the reference condition. So, so far we've gone through an extensive public process for adopting a biological objective for the CSCI. It started in 2016 with our triennial basin plan review. We released 2 drafts for public comments in 2018 and 2019. And in 2020, released proposed revisions to the 2019 draft for public comment. And then we had a board hearing in November of 2020, which was extended to December of 2020, where it was adopted. And throughout this process, we held multiple public workshops. We met with various dischargers and NGOs and gave presentations like the one today. I should also mention scientific peer review. So basin plan amendments are required to undergo scientific peer review, independent scientific peer review. That happened for this project. We had 4 peer reviewers. All 4 supported the project and approach, and they specifically supported using a reference approach for setting the objective. They really liked the inclusion of intermittent streams, and they liked the use of a modeled index, just what the CSCI is, and the percentile approach for setting the actual objective itself. So in regards to the public process, we did make a change in response to comments, quite a few changes, but one of the main changes of focus has been hardened stream beds. And so basically one of the changes we made from the 2019 to the 2020 revisions, which were adopted, was removing the applicability of the CSCI as an objective for hardened stream bed segments. The comments that we received really focused on these stream segments. And I want to be clear that the CSCI works in these stream segments, and they can be restored. They've been restored throughout the San Diego region. However, we know that the concrete really must be removed from the stream bed for restorations purposes. There's some data from the Stormwater Monitoring Coalition on the left shown here that these stream systems just are not able to get a good CSCI score with the concrete in place, which is not really surprising. However, we still feel the CSCI is a reasonable objective to use to protect and restore these stream systems. That position hasn't changed. Basically, what we want to do is gather more information on the restoration timeframe for these stream segments, at which point we're going to come back to our board to either include them with a biological objective or potentially address these on a site-specific basis. So our next steps, since our regional board adopted back in December, the next step is to go to state board for consideration for adoption. The state board public comment period ended back on September 22nd, which means state board's got to respond to the comments and set a state board hearing date. That has not been done yet. So we don't know when a date for that hearing will be at this point. If state board adopts the objectives that or approves the adoption by the San Diego Regional Board, then it goes on to the Office of Administrative Law and then gets submitted to US EPA. So I thought it was pretty important, though, to not just focus on the CSEI and that objective. Really want to talk about our next steps. So I talked a little bit about revisiting hardened stream beds. We're going to kick off some information gathering efforts for the inclusion, looking at it, like I said, a site-specific basis, or if they should be done region-wide or watershed-based or something to that effect. Our board has also signaled that they want to add another biological objective for algae in streams using the Algal Stream Condition Index. And right now, through SWAMP regional funds, we're funding the development of a molecular index for algae, basically a ASCI equivalent that's molecular based. And at the same time, we're using SWAMP funding and working with a lot of partners to develop indices for other priority habitats for those biological beneficial uses. We're looking at indices to basically monitor intermittent and ephemeral streams during their dry phase, basically when they're dry. And then we're also working on developing some level 3 monitoring tools and indicators for eelgrass beds. So that's really where we stand in Region 9, San Diego region today. So, but I wanted to be sure to thank the countless number of individuals and many agencies that really helped get to the point we are today, and who are continuing to help us in terms of adopting future biological objectives down the road.
Awesome. Thank you, Chad. As we wait for, we just got some questions. I had a question for you, but it's okay. So first question that we've received is, have you been able to define reference conditions for systems as spatially and temporally variable as your various temporary stream types?
Yeah, it's a good question. So for the streams that we have under the CSEI, the reference pool for those include intermittent and perennial streams that were capable of being sampled, basically developing a BMI community that could be sampled within a set index period. One of the challenges has been how to apply that reference, kind of the reference definition to ephemeral streams, because a lot of those have much smaller watersheds and have some processes that can impact them that aren't easily picked up by things like GIS. So we're kind of working on that right now.
Next question is, which beneficial uses are you associating the CSCI objective to?
It's a good question. I should have been more specific in that. So specific, like the two beneficial uses that the CSCI are really directly applicable to are the warm and cold beneficial uses in our basin plan. Those are really for stream ecosystems, and they specifically call out benthic invertebrates in them. However, we know that there's a lot of other beneficial uses related to biology that are dependent upon the BMI community and their conditions, things like rare threatened and endangered species like Southern California steelhead.
We have time for one more question. What additional information do you need to gather in order to develop CSCI objectives for hardened stream beds?
Good question. So really, we want to look at the time frame for restoration and mechanisms for restoration for removing the concrete from these hardened stream beds. And we know that they exist in a variety of watershed settings, up near the top of watersheds, down at the very bottom of watersheds, that can have an impact on that. So that's really the kind of information that we're looking at gathering before bringing back an objective or objectives. Don't really know if maybe it's CSCI, maybe it's the ASCI. That's the kind of information we're going to look into.
Great. Thank you so much, Chad. And thank you to everyone for your questions. I'm going to transition on to our next presenter, but Chad will be available to answer the remaining questions that have been submitted. So no worries. Thank you, Chad. Thanks. All right. So as our next speaker gets control of the slides, I'm going to introduce him. So our next speaker is Rafael Nazor. So Dr. Rafael Nazor is a freshwater biologist who specializes in freshwater bioassessment methods using benthic macroinvertebrates and algae. Working at large temporal and spatial scales, he has improved precision, accuracy, and sensitivity of bioassessments using the reference condition approach. In addition, he has studied the population genetics of rare and endangered invertebrates endemic to the vernal pools of California. His current research areas focus on the ecological impacts of hydrologic alteration, particularly in intermittent and ephemeral streams. He received his BA in neuroscience and behavior from Columbia University in 1999 and PhD in environmental science, policy, and management from the University of California, Berkeley in 2006. He joined SWIRP in 2006. So I'm pleased to introduce Rafi. Do you have control of the screens? The screen, on screen.
Excellent, thank you. Thank you for that introduction, Shuka. And actually, thank you, Chad, for that's actually a really good setup for what I'm going to talk about today, which is to provide you guys with an update on some recently completed and ongoing studies on assessing biointegrity and biostimulatory conditions in modified channels. So Chad highlighted how this is an important issue for his region, sort of establishing the breadth of applicability of biological objectives and what to do to manage these systems. And so I'm going to touch on some of the research that we're doing that will help his board make some of these decisions. And I also want to highlight my co-presenter, Scott Dusterhoff from San Francisco Estuary Institute. So as you guys have heard already several times, bioassessment indices such as the California Stream Condition Index, they are able to reflect the combined impact of all the stressors that are affecting the water body, in our case, a stream. And this is, like I said, this is one of the primary advantages for bioassessment, is the ability to get a holistic measure of the combined impacts of water quality, physical habitat, hydromodification, all in one measure. The flip side of that is that you can sometimes have a hard time picking apart the impacts of each of these individual stressors. So, and this is particularly true in modified channels, which can so pervasively and severely modify habitat conditions that it can be really difficult to see what's going on with our water quality. And that means that when we have programs that are intended to improve water quality, it's hard to know if they're working in these modified channels. So we need to have a better understanding of biological integrity in modified channels. And to go about this, we're trying to propose a number of classification systems that really speak to how biological integrity can be supported in modified channels. One thing Chad hinted at was that there are certain types of modifications, hard bottom channels, that need to be treated differently from other types. And that really kind of touches on what we're looking at. We need to have different sets of conversations about different channel types and really set appropriate management goals for our monitoring programs or our policy development. So how would we use these classes? One primary use is to identify classes of channels that are rarely meeting our standards, whether they're reference-based standards or other types of objectives. And you can, again, develop appropriate policies or management plans for each class. And in addition, set appropriate restoration goals for these different classes. Another use is to look for how biological integrity responds to stress in each of these classes. We can hopefully identify whether certain types are more responsive to water quality improvements than others, and therefore that can help us pick appropriate management actions that really will improve conditions in these systems. So it's these sort of two different aspects, understanding the range of conditions and also understanding their responsiveness. So we've been talking about this issue for several years. Chad highlighted a handful of studies that the Stormwater Monitoring Coalition has done, but there's actually work done in other parts of the state. SFEI recently published a study on flood control channels in the Bay Area. I encourage you to check it out. And these studies have all really focused on bed and bank material as the primary way to describe channel modification. And that really appears to have sort of the most widespread support among watershed managers in terms of how to understand what channels are modified. There are, however, a number of different approaches you can take to attaining information on bed and bank material and that these studies have taken. The Stormwater Monitoring Coalition based their classifications primarily on site visits supplemented by photo interpretation. The SMC developed some simple checklists that really highlights some of the key features of modified channels to identify what types and where the modifications occurred. And this is really great because when you have this information, it's it's perfectly associated with your bioassessment data because it's at the same location. It's very high validity because you're actually observing the reach itself. But the drawback is that you can really only look at one site at a time. So while you can generate really great data sets this way, you're not going to get a map showing you where all your modified channels are. I'll contrast this with the approach taken in the Bay Area study, where they instead focused on shapefiles representing facilities that were constructed by the Stormwater Management Program up in Santa Clara County, as well as Sonoma County. And what they did is they crosswalked some of these inventories to categories that were similar to what the SMC had, focusing on whether the bottoms or the sides were hardened. And you can generate very beautiful maps that really give you a big picture view of what's going on in this watershed. The drawbacks are that you don't have perfect confidence that you've correctly characterized the site where your bioassessment data was located. You have categories like they call here mixed, which can represent some ambiguity as to what the actual channel looks like. And so there's a handful of drawbacks, but so ultimately you need a variety of approaches to really get the information you need to help manage modified channels in your watershed. The two studies are starting to show a more consensus about what these modified channels look like. As Chad mentioned before, the indices work. They are correctly showing us that conditions tend to be poor in our modified systems compared to natural systems. As Chad mentioned earlier, when you're looking at entirely hardened channels in Southern California, they were rarely, if ever, attaining reference-based thresholds or fairly consistently low scoring. And we see the same pattern in the Bay Area as well. Both Bay Area and Southern California studies show that the soft bottom channels represent a fairly diverse group. They tend to be mostly in poor shape, but there's a wide range, and we don't really have a good understanding of what's driving that variability. That's actually becoming a much more important issue, particularly for folks in the San Diego region, where these biological objectives do in fact apply. They're not really sure what to do about trying to attain it for those systems. In Southern California, we've gotten a really good idea of how these channels respond to stressors. But we're seeing is that in hardened systems, at least, most of the responses are fairly muted. So in these figures, you have hardened channels shown as blue dots and natural channels shown as red dots. And we're looking at a range of stressors on the x-axis. When you look at things like specific conductivity, natural channel scores decline as conductivity increases, and this is what you'd expect. But you really don't see much of a response in hardened channels. Conditions are fairly poor at a wide range of water quality conditions. And this is true for a wide variety of habitat or water quality parameters, although not all of them. For example, that last figure shows you how the scores respond to shading, and this could reflect the role of water temperature or provision of leaf litter for riparian vegetation as one way of potentially improving scores in hardened channels. We're also starting to see how context really affects things. And this is, we've barely scratched the surface on this in Southern California, but we have started to observe that there are a number of high scoring hard bottom channels, but they're all kind of the exceptions that prove the rule. So here's a stream way up high in the watershed of the Santa Clara River that receives discharges from the Drinkwater Reservoir. It's a fairly steep, hardened channel that scores well. But the context is it's in an almost completely undeveloped landscape, as you can see in that photo there. So these are the circumstances in which hard bottom channels can sustain high CSCI scores. This may not be a very appropriate management goal for something like the lower San Diego River. The Bay Area actually got to look at this in a much more in-depth way. And what they found out is that imperviousness can affect condition even in hardened channels, watershed imperviousness. And you can see that in these red and orange dots. These are two classes of modified channels, the way that there's still actually an upward slope at that low end of the impervious area, in contrast to what you see in the green pattern, where you see a much more prolonged length of responsiveness. It sort of flattens out later. The Bay Area was also able to look at the role of channel maintenance, although those results, I would say, are a little bit less conclusive. They looked at a variety of typical maintenance activities like sediment removal, vegetation removal, or herbicide application, and both in hardened and softer natural channels. They don't really see a big difference in scores. However, this was held back a little by the fact that we couldn't really associate the time of the maintenance activity with the timing of sampling. We simply know that there's that type of activity occurring in those channels. So maybe new information might help us get some more insights here. So what are we working on now? I'll talk to you about some studies that have already been completed and are published. So there's actually a variety of studies by the State Water Board, the Central Valley Regional Water Quality Control Board, as well as the Stormwater Monitoring Coalition of Southern California. And a lot of these studies are focused on sort of confirming some of the patterns in one part of the state and other parts. We're basically trying to look at existing bioassessment data and see what we can find out about their channels and see if they uphold these patterns. And we're also strategizing new ways to actually get scores for streams in that lack definable watersheds, which is a particular widespread situation in the Central Valley, particularly in our canals down there. We're going to be expanding these studies to look at biostimulatory endpoints like ash-free dry mass or benthic chlorophyll A. And we're actually going to start focusing on management to improve conditions in modified channels. So how are we generating info on hundreds of sites with bioassessment data? We're going to be conducting site visits and field work, but we're also going to look at some related designations in various plans and documents, as well as start getting more use out of our PHAB data. And I think that's something that's probably going to be of interest to this group. So the Central Valley has an inland surface water plan that was drafted actually back in the 90s, and I don't think it's ever been formally approved, but it proposes a way of identifying modified channels by looking at data provided by stakeholders to the regional board, focusing on things like where the water is coming from and whether the channel has been straightened. And they have a bunch of water bodies classified in the appendix, like natural ag-dominated streams or constructed facilities. And when I look at the bioassessment data from those streams, and this is data from all of Region 5, not just the Central Valley floor, we're actually starting to see a pretty stark pattern. Similar to what we saw, modified streams are scoring lower than natural streams, although there really isn't a big impact of whether the water in those channels are return or supply. But what I think is most interesting is that when you look at a category of streams called constructed facilities, so those two panels on the right are both modified, but constructed ones are either artificial or implanted in historically dry washes. Those are scoring distinctly lower than other types of modified channels. So this is some new insights we're getting in the Central Valley. Physical habitat data would be great to use because we have so much of it, and we could then classify thousands of sites if we were able to use it. I'm focusing on pebble counts as well as our human influence measures as two ways of trying to infer the presence of modified channels. So our pebble counts, many of you know how we do this. We look at 21 transects, 5 locations in each transect, and we record the size of every pebble we encounter. Although if we encounter a pebble made of concrete, we record that. So the percent of concrete in the pebble count is an overall measure of armoring, at least on the bottom of the stream bed. This doesn't really tell us anything about soft bottom channels or earthen engineered channels, and it doesn't tell us about hardened channels where there's been a lot of sediment deposition on top. But we are seeing pretty good response where scores are highest as long as that's below about 10%. And that gives us an idea of how we can start classifying streams this way. We're also looking at human influence, where we look at what's going on in the riparian zones. And there's a few categories that suggest that there's been armoring, like walls and ripraps or buildings in the channel. And I basically looked at where these activities were occurring on the bank or in the channel. And I was able to calculate within a reach, what percent of it has armoring on one side, armoring on both sides, or no armoring at all. So I can sort of divide it up into these three compartments. And we again see a pretty good relationship with CSCI. These blue contours show that where the concentration of high scoring sites are, all above 0.79. And you can see that, of course, unarmored reaches where it's completely unarmored are where your high scores are most likely to occur. But there is a suggestion that armoring on one side can be tolerated to some extent more so than armoring on both sides. This is, I would say, preliminary. Putting the two pieces together, you're starting to get a good idea of what's going on channel bottom and sides. Although, like I said, this doesn't really capture what's going on with earthen engineered channels. So the next steps, we're going to do some field visits to confirm the accuracy of these classifications and sort of come up with some sort of finalized categories. And we're going to start calculating ranges of scores and biostimulatory patterns in each class. We're going to do the statewide as well as in regions where we have sufficient data, which is at least going to include Southern California, the Central Valley, and the Bay Area. We're going to also look at how both the CSCI and the algal index respond to biostimulatory stress within each class. The SMC in Southern California just approved of a new study to sort of extend these findings. And they're primarily focused on what can be done to improve conditions within existing channel forms by looking at not just water quality, but flow management and maintenance activities, as well as how we can improve conditions by restoring natural features. What's the timeline for improving those conditions? And with that, I'd like to thank you and take any questions you guys have.
Thank you, Rafi. As we're waiting for questions to come in, I was taking a look at that field data sheet that you showed a little bit earlier about how to classify, or the documentation that you need to collect for channel standardization. I just wanted to know what your opinion is for like the best approach to standardize channel classification. Like, where would you start? Is there just a lot of, go ahead.
That's going to be like a key outcome of the studies, that we're going to have some sort of simplified key features to focus on. I think it's not hard to tell when you have, a channel that looks like the one on the top, is it modified? That's not really going to be a challenge. It's really, how do you discern the earthen engineered channels from natural channels that might have had a lot of disturbance going on, but are still essentially natural? And I think we're going to try to focus on what are the key features to focus on there. Is it straightening? Is it, some sort of uniformity of shape that we're missing? And so I think we'll probably end up with key recommendations that can be added to our protocols for that.
Okay. Thank you. Looks like we actually did get some questions in, so I'll just read them out loud for you. What habitat types do you think are best suited for restoration based on your findings? Are hard bottom streams too altered to be good candidates?
I'm going to say that I don't think we know. I don't think we've done enough restoration activity. And even if we have, we've not done enough research on them to have a sense of what's most likely to work. So I think, those are great questions. I think we do know that restorations do need to take a watershed scale perspective and can't just focus on fixing one reach at a time. Those are unlikely to succeed.
Okay, and the next question that we have is, upcountry ranchers use BMPs like livestocking and willow recruitment to restore stream banks. Is that deemed a modification?
That's a good question. So I would say I've been using the definition of modification as being a deliberate change of the channel morphology. So I'm not talking about, incision that might occur that wasn't a deliberate intentional change. There's probably a lot of gray areas, and I think what you're talking about fits into that, but I would say that's an activity that is not intended to alter the channel form, so I probably would not consider it, but I suppose there are cases that could vary.
Okay. Thank you. I don't know if we're going to get any more questions, but if you do submit questions or I'm so sorry, my video is not on. Sorry about that. But if you do have questions or you're in the middle of typing it, go ahead and submit your questions. I hope Rafi will be here available he can type answer like his responses to you. So just go ahead and submit any questions that you have. So that's actually it for this short session. If you have any additional questions for our presenters today or any of our presenters today, you can either email the SWAMP email inbox, or you can email me to get contact information for any of our presenters. Wants to thank both Chad and Rafi for presenting today. Thank you so much. I'm gonna actually give this off back to Ali so that we can transition to the rest of the day. So thank you.
Be able to get my.
You're good to go.
All right. Come on, everybody, gotta toggle between things here and get the volume up. Bear with me. Okay. So, yes, thanks again to all the presenters today. There were some really great talks, excellent questions, and good discussion around those questions. And like we've mentioned throughout the day, if you'd like to follow up with any of the speakers, feel free to reach out to them if they've made their contact information available. Otherwise, you can always reach out to that swamp@waterboards.ca.gov email, or to either myself or Shuka, and we can connect you as well. So that's it for today. I think we're going to wrap things up a little bit early. I do want to remind you all that there's a poster session from 2 p.m. to 3:30 p.m. today. And again, go to the agenda for access to that poster session Zoom room. And Angela spoke to that earlier. I think there's 9 different posters. So give it a peek. And then again, tomorrow we've got more talks. So we'll reconvene here, I believe, at 9 a.m. again. And then we'll get into our estuary panel. And then the second half of the day is that CalSFS sponsored workshop, where we'll have a panel of tribal folks to speak about traditional or indigenous ecological knowledge. So please tune in for that. And then finally, before you all go, I just wanted to quickly I threw this slide up earlier today. I'm not sure if you all can see that very well, but we do have a project going on. And Peter, I don't know if you're on, if you wanted to say some things, I'm happy to.
I am on.
Yay. Hi, Peter.
Hi.
So I'll hand it over to you if you'd like to talk to everybody about these eDNA kits.
Yeah. Hi, everybody. I'm Peter Haupt. I'm with the Surface Water Ambient Monitoring Program, otherwise known as SWAMP. We're searching for partners that would like to participate in an environmental DNA pilot project. As you've heard, eDNA is a new way of examining aquatic ecosystems, and sampling is super easy. Just filled out a field collection form on your phone and push some water with a syringe through a filter, send that off in the mail, and all of the necessary equipment, including a postage paid envelope, is provided by SWAMP free of charge. In return for sample collection, the SWAMP eDNA metabarcoding monitoring and analysis project, CMAP, will provide analysis and support in the form of direct communication with the project leads, a web portal that allows users to look at the map, click on their collection site and stations are occupying their water, Knowing this information is useful in myriad ways, and CMAP scientists are always available to answer questions and help participants analyze their sampling results. So we're seeking partners from a broad range of backgrounds, locations, and skill sets. One of the challenges of this new way of collecting data is to automate the field forms, make them easy and user-friendly while allowing us to receive information of known quality. So SWAMP is searching for tribal and community science partners, educational partners that would like to participate in the eDNA sampling project. For the past 2 years, we've been collecting phytoplankton and fish results, but this year we will expand to include macroinvertebrates as well. So there are 2 ways to participate: passively by joining our email list and keep up to date on what CMAP is up to. The other way is by actively participating with us and becoming a member and collecting samples. There are a couple of forms to fill out that are linked in the chat. And that's my pitch. I hope you join up. Thank you.
Awesome. Thanks, Peter. And there's actually a question for you if you want to hold on, which is it possible to participate outside of USA, out of America?
No, we're going to keep it in California. That's one of our goals, is to show how we can expand our footprint statewide. So that's really, it's subject to California only.
Cool. Well, thanks again, Peter. And all this information is here, folks. So I'll keep this up. So you still have access to the email list and request for free kits. And I think with that, yeah, we will see you all tomorrow. I want to, again, just express sincere gratitude to all the speakers and participants, and for another great CABW day 1, and be back here tomorrow for lots of great talks. Thanks, everybody.